Okay, so you can hear me, right? You can hear me?
Yes, sir.
Good morning, sir. Good morning, sir.
Good morning, madam.
Good morning.
Morning, morning.
Good morning,
Good
Professor
morning,
Anjali. Nagaraju, Dr. Nagaraju.
Yes, sir. Not
Dr. Nagaraju, can you
Nagaraju,
please
sir.
switch on your video and audio? Dr. Nagaraju. Dr. Nagaraju, can you please switch on your audio and video? Madam, am I audible? Anjali, madam.
Yeah, yes, sir. You are audible, sir.
Yeah,
I joined already.
Yeah, I think you are having
Good
the
morning.
list of the presenters with you.
Yes, sir. Yes, sir. I am having. Yeah.
Yeah.
That yes.
So, madam,
I
now,
downloaded. I am having that.
yeah. Now what happens? First presentations will be there 9 to 11 o'clock.
Yeah.
Followed
Okay,
by
sir.
11 to 12 will
First
be the
presentations
lecture
will be
batch.
there. Then. Okay, sir. Okay, sir. Yeah. First is D. Rama Rao from PR Government College.
Yes.
Yeah, sorry, madam.
No problem, sir. No problem. First,
Good morning, Anjali.
only. No problem. Good morning.
Good morning, Anjali,
sir.
madam. Yeah, myself, Nagaraj,
Good morning.
madam.
Good morning.
Nagaraj, can you please go to the next slides?
Yes, sir.
Otherwise, I will share. I will try to share the screen.
Sir, voice is echo.
Can you please make me co-host?
Yavarama? Okay. Sorry, Anjali, madam.
No problem, sir. No problem.
No.
Please carry on.
No. Actually, the first person, D. Ramarao, is could not able to the first person, Ramarao,
Okay, sir.
he could not be able to presenting first.
Okay, sir. He is
I
not
think,
able to present. No problem. Okay.
Yeah, I think we'll move on.
We have to go for second, sir.
We have to go for second.
Yeah. Sir, 1 minute, sir.
Okay.
Nara, sir.
Yes, sir.
Can you please make me co-host and stop sharing from your side?
Hey, you are already in the co-host.
Yeah. Just 1 second.
Voice is echo. I don't understand.
Let us wait. 3 more minutes are there because for 9 o'clock.
Yes, sir.
Yes, sir. Let them come because we should join before now, so that's fine, sir. No problem.
For GITAM, 9 may be okay, but for others, takes a little time.
Yes, sir. No. We are hosts, so we should be in time. Baki, so people should also be in time. But okay, no problem.
Narazu, Vandana is with you, na?
Yeah, Vandana, she's with me.
She's
sir.
taking care of call.
Yeah. She's calling me.
You are also in campus, sir?
Yeah. Everyone is on campus, madam.
Okay, sir.
Sir, some echo coming, sir. Venkatan sir. Some echo means some noise is coming in outside. But where it is?
Here, I won't fade, but someone is speaking. One of the participant. You please
okay.
try to please. I will announce. Just,
Yes, sir.
yeah, I will announce. I will announce. Okay. Good morning to one and all. I welcome all of you to the second day of International E-Conference on Advances in Science and Technology for Betterment of Health, Environment and Energy. The program is scheduled from 1st to 3rd, 2020. And today we are having two sessions. A morning session from 9 a.m. to 12 noon IST, Indian Standard Time. Afternoon session from 1 p.m. to 4 p.m. Indian Standard Time. So today we have two invited talks. The first talk will be from 11 a.m. to 12 noon Indian Standard Time by Dr. Moses from Kenya. And the second talk will be in the afternoon session from 1 p.m. to 2 p.m. by Dr. Edith from South Africa. So today morning session, the resource person, as I told, Dr. Moses from Kenya, and the chairperson of the morning session is Professor Anjali Jha from GITAM Institute of Science, Visakhapatnam.
Good morning.
Yeah, good morning and welcome you, madam, officially. Okay, so
yes, sir.
now,
Good morning, sir. Thank
yeah.
you for giving me an opportunity.
Yeah, so the coordinator of morning session is Dr. K. Nagaraju, GITAM School of Science, Bangalore. Nagaraj sir.
Thank you, sir. Yeah, thank you, sir.
Yeah. So
can you go ahead, sir?
Yeah, today we have two sessions. This is about the schedule. Morning session, 9 a.m. to 11 a.m. We will be having oral presentations, followed by the invited talk. And at 12 noon to 1 p.m. Indian Standard Time, the lunch break. And then 1 p.m. to 2 p.m. will be the invited talk by Professor Edith, and followed by 2 to 4 p.m. oral presentations. So today morning session, we have in total 14 oral presentations. All of them are from environmental field. It will be coordinated by Dr. Nagaraju and chaired by Professor Anjali Jha. So with this brief introduction, I would like to hand over the session to the coordinator of the session, Dr. Nagaraju. So please take over the session and welcome the chair, and please go ahead. Thank you.
Thank you, Prof. Venkatnath. Yeah, I'm Dr. Nagaraju Keru, coordinator of this event, International E-Conference on Advances in Science and Technology for Betterment of Health, Environment and Energy. Good morning and a warm welcome to all participants. Day 2 of the event. I am very glad to you all for your support. And yesterday we had a great finishing with good 2 sessions. It was more informative from the distinguished speakers. One from Professor Ramkrishna Rao, another one is Professor Mastosi, as well as we enjoyed with all yesterday presenters. And I am very thankful to all audience and participants. I hope today you are also would be enjoying and getting some scientific information from the today's speakers. One speaker from Dr. Moses from Kenya. He is the innovative speaker, and he is going to be deliver about the sustainable green oxide crystalline and cellulose composite materials and their applications. And the other one is Prof. Hedges from South Africa. She is going to be deliver multifunctional nano materials with thalocyanine for their use in the catalysis. Thalocyanins with the magnetic nanoparticles are employed for the photocatalysis and their photodegradation for industrial pollutants. She's going to be deliver how the middle research will be helpful to a green credentials, green chemistry credentials. all we know we have a 12 green principles. Out of 12 green principles, how many principles we are obeying while doing the synthesis of materials and performing their catalysis activity in their making of catalysis research, like photocatalysis or photodegradation studies or water-based water treatment or synthesis of organic synthesis, so on, like that, etc. I hope you guys are enjoying today lecture based on the synthesis of materials. How will you reduce the chemical waste? How will you reduce the hazard of substances or toxic substances while you making the green field synthesis in the material research point of view? Once again, I'm thank you all. I've been very happy to. I've been received huge number of abstracts as well as the presentation today. Today's session is very crowdy. I'm very happy to that. We in either morning session and afternoon session, all are oral presentation only. I'm very happy to that also. I am requesting you all further support and cooperate with me to successfully finishing this two session, morning session and as well as afternoon session. For the sake of time being, Dr. Moses, he will be joining us 11 a.m. at the Indian Standard Time. So that we will start today's session, first oral presentation, followed by the invited talk. Sorry for the inconvenience caused with the and as well as this session along with me, Professor Anjali Jha as a chair of this session from Department of Chemistry, GITAM, Visakhapatnam branch. Welcome to Madam, part of this event.
Thank you, sir.
Yes, screen is yours. You can go now, Madam. Thank you so much for this.
Yeah, before going to that, Madam, Dr. Anjali, Madam, please, Nagaraj,
yes,
can you please announce the regulations formally?
Yeah. Actually, we have a two session, morning and evening. Morning session, all 13 or 14 are oral presentations. We are giving a prizes on the based on the best performance of the oral presentation. And the morning session, we are giving the one best poster, best oral presentation, as well as evening also. In afternoon session also, we are giving the best oral presentation of the pupils. We have to select the best presentation. Thank you, sir.
And moreover, for each oral presentation, 10 minutes will be given. Out of 10 minutes, 7 minutes will be oral presentation by the presenter. The balance 3 minutes will be for the discussion part. So first 7 minutes will be presentation. The next 3 minutes will be for the discussion. So whenever the Nagaraj Garu or Anjali Jha Madam is going to request the person, so automatically they are going to call the next person also to be there. Thank you. Madam, please unmute yourself, Madam. Anjali, Madam.
Out of how much marks we should give marks? 10 marks or something?
No, you give the grade yourself. No issue.
No issue. Well, like ABC I should give, or out of 10 marks I should give, sir? Just
out
one
of 10
minute.
will be easy, please.
Okay, sir. Okay, sir. Thank you. Okay, so can I start, sir, with your permission? Can I call first presenter?
Madam, we can start with Tolo, Madam.
Or
OPENB
Mr. Nagaraju, are you going to call?
Yes, madam. OPENB 012, Madam. You can call.
Yeah. You told us first is not there, so second we should start. So second is that Mr. This one. No? Okay, I am making me unmute so that disturbance should not be there. Presenter, I request Mr. Chandrasekharan to present his work.
Okay. Good morning, ma'am. Good morning to all the organizers, all the attendees. I'm Dr. Saravanan Chandrasekharan, working in Presidency University. Today's my talk is biodegradable material for electronic. First of all, before going, ma'am, next slide. Next slide, ma'am, please. Before going to my main topic, I would like to thank my postdoctoral research work supervisor, Dr. Janet, and all my collaborator, Dr. Alvara.
One second, Nagaraj sir, please maximize. Fine.
Okay, is that okay?
Fine.
It is
Sir,
not
please
full,
go
ma'am.
ahead.
I could see only 3/4 of the slide. I couldn't able to see all the slides.
Yeah,
so
it's
this
not
is
in
my,
the center, sir.
yeah, it is not center. Okay, yeah. So
Nagra,
first of all, I would like to
fine.
First of all, I would like to acknowledge my collaborator as well as my postdoctoral research work supervisor. This is the work I carried out in University of Bath, UK. That is my last postdoctoral research work. And then I would like to thank our Dr. Alvara, who did the biodegradable studies, Dr. Remy Zugumbar, and then Pechman Irvani, Gary Kirwan from University of Warwick, and then Baljinder, Dr. Baljinder, who helped me to do fire deterrency test, and James Acklin, who helped me to do the life cycle assessment, and then all other project collaborators from Oxford University and Newcastle and Lambda University. Next slide, ma'am. And all my colleagues from President's University as well as the organizer GITAM University for the good opportunity to deal with this lecture. So this is the main topic. I would like to give what is e-waste. I think I no need to explain much more about the e-waste. E-waste is electronic waste we are disposing after the usage. But when after throwing that, have you ever thought about that? What are the valuable metals or toxic materials available in e-waste? So most of us, we know that valuable materials are there, but we don't know how to recover those valuable materials available in e-waste. Okay, for that, we developed a material which can be degradable at the end of the use, very easy to recover the valuable metals. Also, we can very easily dispose the used electronic waste. Okay, that is the main intention of this research work. Okay, so mainly we have concentrated on the printed circuit board because, as you can see in the slide, that is the main part of every electronic goods. Okay, so we are taking as a mobile as the example, but in every unit there is a circuit board is the main one. So which is contain all the precious metals, wood and other materials. Next slide, ma'am. Next slide. So these are all different materials available in the electronic waste. Ferrous and non-ferrous materials, like gold, silver, platinum, palladium, and plastics, glass, and wood, and others. So there are 38% in ferrous and 28% non-ferrous. From non-ferrous, extract the materials, but throwing the plastics, glass, wood, other things, it is make the landfill the waste. Okay, so for that we need to make a good material which can degrade at the end of the use. So these are the precious metals and the platinum group metals. Also, it is contain hazardous elements like mercury, beryllium, cadmium, and lead and antimony. So that thing also should be carefully need to dispose. Okay, so we are taking gold as one of the example. If you extract the ore, we can get only 3 gram of gold out of 1 ton of ore. But at the same time, if you treat properly, if you can recover 300 gram of gold out of 1 ton of e-waste or phone waste. Okay, so apart from gold, it is also contains silver, platinum, aluminum, and other copper also. So if you save this one, if you recover this kind of metal, ma'am. Next slide, please. Okay, see that if you make any electronic goods, the different metals is coming from the different region of the world. Okay, so if you recover the valuable metal from out of e-waste material, there is no need to dig anything, and then no need to do for any process which is involving energy. Also, it is directly affecting the environment, because extracting metal from out of ore, it is not an easy process. It has to do many process. That is why if you recover this valuable metal out of used e-waste, it is very useful in economical and environmental point of view. Okay, please go next slide, ma'am. Okay, so this is the one iPad and then iPhone. If you recover this metal and then reactivate, again you can reuse to make the electronic goods. This is a very good economical, in economical point of view and environmental point of view, it's a very good system. Next slide, please. So these are all existing technique. Is most of these techniques are involving heat. Okay, so where it is directly involving energy. So to except a few methods, it is involving heat and energy related. That is why we need, next slide, ma'am. That is why we need to develop a material Okay, so you see that this is the current method in African country, China, as well as in India. We are cooking the metal e-waste in order to break the polymeric material, which is not degradable, which is not biodegradable. Okay, this is the iPhone where it is contain all bromine, chlorine, lead, and mercury. This is iPhone 5, which is contain all the environmental hazardous. So even this also is mixed with the air. Go, ma'am, the next slide. Okay, so if it is mixed with the air and water and then soil, so what human being or living animals, whatever maybe, we are affecting many diseases, okay, like head and cancer and other asthma problems. In order to avoid this one, in order to overcome the existing recovery method, which is involving more energy, which is not good for the environmental. So if we make a material which can biodegrade by enzyme, that is a meaningful work. Okay, next slide, ma'am. So in recently, there is John Roche's group. They have developed a biodegradable electronics, which is basically from silk material, which can soluble by simple water molecule. Okay, so simple water we can treat with that. Then that base material, which is polymeric one silk, we can dissolve and then we can recover that. Come on, the next slide. So keeping in mind that, next slide, man, please. Next slide, please. Hello, next slide, ma'am. Yeah, this is a method we can recover. If you make the polymeric substrate material, which is the base material for electronic circuit board, which can and at the end of the use, and then by the enzymes, we can disintegrate the PCB as well as the metal which is available on the surface, which is generally available in the circuit board. We can recover by the simple filtration. So we can, by this way, we can recover the valuable metals by easy way. But this material, whatever is the middle one, it's a printed circuit board, it should be a renewable resource. It should not be dependent on the petroleum resources. Also, it should not contain, make any hazardous. It should be economical, flexible. Also, it should be non-flammable, then printable and biodegradable at the end of the use. So all these properties bringing in one materials is one of the challenging one. That is why we have taken this this research project is mainly for making this kind of material. Next one. So based on that, we selected polysaccharides, polylactic, polyhydroxy butyrate. But polysaccharide is cellulose is most abundant materials in the world. That's why we have selected this cellulose as the base material. Next slide, ma'am. Why? Because this is availability, biocompatibility, biodegradability is also mechanically robust. But the surface also is very easy to change because it's contains the hydroxy group. But the disadvantage is it is insoluble. It is not very easy to processable. Hydrophilic surface, also it is compressible. So all these things need to overcome. So based on that, we have published recently one paper, and then other papers also on the pipeline. Next slide, ma'am. So this is the entire process. First, we dissolve the cellulose in ionic liquid. We added flame retardants into that in order to increase the flame retardancy. We made a film, and then we removed the ionic liquid. We recovered. We can reuse several times. Also, these are a hydrophobic agent, which is surface treated, where the increase the water barrier property. Also, the surface is more suitable for printing. Okay, next slide, ma'am. So this is the flame retardancy when we add cellulose with the laminate clay. As you can see here, only cellulose is leading more flame. When you add 10 and 20%, in 20% it's not leading that. However, it not meet the international standard. Next slide, ma'am. So we varied the different fillers, flame retardants from calcium silicate to aluminum oxide and calcium carbonate. All these things have got failure to meet the international standard. But when compared upon a polyphosphate, it was very good fire retardants where it is increasing or met the international standard. Next slide, ma'am. So then if you take the surface functionalizations, say for this lotus leaf, which is with water, okay, it should not interact with much water because since it is a cellulose material, very easy to absorb the water. So we need to change the surface to suitable for water barrier because while using the mobile for any electronic goods, it should not affected by the moisture. So that is why we treated a different hydrophobic agent. If it is the contact angle value is less than 90, it is hydrophilic. 90 the contact angle values is the reaching 120 degree. So next slide. Next slide. Okay, so this is the one with the cellulose with the calcium silicate. As you can see that the contact angle almost is 140 degrees, 140 degree. The angle, water contact angle, the red line, which is the TOS, is a silica, which is the one is most effective hydrophobic agent. E2CA also, ethylene cyanacrylic acid also, is one of the efficient hydrophobic agent for the surface changes from hydrophilic to hydrophobic. But the ODPA is not suitable because ODPA is not much interact with the calcium or the other metals which is available in the cellulose film. So when you go for ammonium polyphosphate, okay, we have treated dip coating method. Okay, in the dip coating method, we used to do two different solvent. One is ethanol and toluene. More suitable solvent because ethanol is also having hydroxyl group where the hydrophobic agents is interacting, which is avoiding the more coating at the surface, which is giving a less contact angle when you compare with that. The concern about the mechanical studies, we did the elastic modulus, which is defining the stiffness of the material. So in two different relative humidities we have observed, because in the entire world, if you take it to market level, different regions having different relative humidities. So that is the two extreme relative humidity we did. One is 20% and 70%. The dark one is the 70% and the light color is the 20% of relative humidity. Okay, dark one is it's showing that is more flexible when you compare with the lighter one. It means that humidity is playing the plasticizer. So when you go for the printing studies, because if you make the material for the electronic purpose, electronic applications, and the surface should be suitable for making a printing, conductive ink coatings. So when we did this is the contract, the black one, which is near to the whatever is you are seeing in the dark. This is a water, the droplet which is sitting on the surface of that. So when you, as you can see that when you increase the hydrophilicity, hydrophobicity, that place where it is conductive coated is very fine defined structure which is sitting as it is, but the first pictures it is spreading everywhere. It means it is absorbing the conductive ink, which is not suitable for printing. So when you go for different types of coating, it is suitable for the printing studies. Okay, the same materials when we subject to the biodegradability studies with the cellulocast as one of the enzymes. Next slide. Next slide, ma'am. Okay, as you can see that no flame retardants. Okay, it is showing 100%, but at 10 weight percentage APP it is increasing because the APP is ammonium polyphosphate. When it is in the enzyme solution, which is containing buffer solution, it is getting dissolved from, and then it is leaching out from the film, which is giving more porous. Therefore, it is increasing the interaction between the cellular enzyme, where it is showing more activities. At the same time, only ETCA is nothing. Okay, in this, go to before slide, ma'am, the first slide. Okay, first slide. So as I shown you that APP is leaching out from the film. Next slide. Okay, we have confirmed with the FDA here where it is the peak of the phosphate is reducing. Okay, which is indicating that so APP is very good flame retardants, very good material for the mechanical properties, also biodegradations also it is suitable. The surface treated samples also is playing the very good material for the printing as well as flame retardancy. Okay. So next slide. So in summary, we have selected the material which can biodegradable. We did not select anything from the halogen related flame retardants. Also the process is ionic liquid we can recover and reuse. We have confirmed with the NMR where there is no structural changes after subjecting it to the solubility one, because ionic liquid is more costly, but it is reusable. And then the surface we have changed from hydrophilic to hydrophobic, which is more suitable for water barrier as well as the printing studies. Then it is flammable, non-flammable. Also mechanical properties is matching with the existing one. So with this one, I would like to conclude this talk. If you have, in the future, I'm planning to use mainly extending the biodegradable material for other device applications like sensors and batteries. Also currently working, converting the e-waste material into the useful product. This is my main research focus. Okay, thank you so much. If you have any questions, please.
Okay, good, Mr. Chandrasekharan. Good presentation, but little bit you exceeded the little bit time. Just
Yes,
this
ma'am.
is
Yes.
the need of the hour, but I must say, and nice presentation. Congratulations. Good work.
Thank you, ma'am. Thank you so much.
Okay, thank you. So Nagaraju sir, can
Madam,
we go for the next? Can we go
I
for the next?
requesting you, madam, I requesting you if you ask to audience if they have any queries or questions.
I request all the audience, if you have any question, please ask one or two questions because already Chandrasekharan sir has exceeded some time.
Hello, good morning, sir. I have
Good morning.
a question. Sir, Dr. Chandrasekhar, did you check the economic aspect of this? Is it more economical compared to the conventional material?
Yeah, when you concern about the ionic liquid is more costly. As I mentioned mentioned in the last slide, it is recoverable and reusable. So that is the only cost effective. When we did the life cycle assessment, the sodium hydroxide is the hot spot in that. But the rest of the things, everything fine. Cost wise also it is good because cellulose is cheaper, it's mostly available.
Okay, thank
The
you.
flame retardance also is not more costly.
Any other question? Thank you. Thank you,
Thank you.
Dr. Chandrasekhar. Okay.
Thank you, madam. Thank you so much for it.
So can I call Dr. Rashida Khan to present her work?
Dr. Rashida
Dr.
Khanam, GITAM
Dr.
Visakhapatnam.
Rashida Khanam, are you there? Please join. Unmute yourself. Proceed.
I will go ahead in next one, madam.
Rashida.
I think she is not available, madam. I think I will go next one.
Okay. Then
Can you
we
proceed?
go for the next.
Yeah.
Mr. Sugandhi.
Yeah,
Sugandhi.
that.
Dr. Sugandhi. Can I request you to please present your work, Dr. Sugandhi. Please little bit stick in your time, 10 minutes. Dr. Sugandhi,
Okay,
invite you to present your talk.
yes. Thank you, ma'am. Very good morning to one and all. Firstly, I thank GITAM University for giving me this opportunity. So myself, I'm Dr. P.R. Saugandhi from the Department of Chemistry, Dravidian
Sir, it's not audible.
Kupam. So today my presentation topic is preparation and characterization of bio-nanocomposite films incorporated with silver nanoparticles. So ma'am, next slide, ma'am.
Nagaraj sir, next slide.
Next slide, ma'am.
Yeah. 1 second, ma'am.
Okay, ma'am. So, coming to the abstract part, this is nothing but preparation of bio-nanocomposite films. So, bio-nanocomposite films is nothing but, it is a blend of two polymers, that is CMC, which is nothing but carboxymethyl cellulose, a cellulose derivative, and a pectin. So, combination of these two polymers incorporated with silver nanoparticles prepares the bio-nanocomposite films, which is prepared by wet casting method. So for this, the silver nanoparticles are prepared by using the sodium gujava leaf extract, which is nothing but a green synthesis and an eco-friendly method. So later, the prepared silver nanoparticles were characterized by using UV visible spectroscopy, FTIR, and particle size analyzer. Later, after that, the incorporation of silver nanoparticles into the biopolymers were characterized by SEM, XRD, UTM, WVTR, and also antimicrobial studies have been done. So with these studies, we can see that there is an increase in the mechanical properties, barrier properties, and all the characteristics by the incorporation of silver nanoparticles into the biopolymers have increased. Ma'am, next slide, ma'am. So coming to the introduction part, as we know, nanoparticles are nothing but which are ranging from 1 to 100 nanometer, and it is based on the special characteristics like as it is of size, morphology, and distribution. And also we know that nanomaterials are the emerging trends in the field of nanotechnology. So compared to all the nanomaterials, we can see there is a increased production of silver nanoparticles because of its applications like in the field of catalysis, sensitivity, biomolecular detection, medicine, biosensors, application, antimicrobial activity. all this, because of all this increased applications, its production have been also increased from the current years. Next slide, ma'am. Ma'am, next slide, ma'am. So coming to the objective parts, the main objective is first one, preparation of silver nanoparticle by using green synthesis method. So green synthesis method is nothing but eco-friendly without the usage of any harmful chemicals. So next one, incorporation of this prepared silver nanoparticles into the biopolymers. Here biopolymers we used is nothing but CMC, carboxymethyl cellulose, and pectin. Next, preparation of bio-nanocomposite films and its application in field of food packaging. Next slide, ma'am. Next slide. So coming to the experimental method. So experimental method here, the preparation of film. How do we prepare the film? So film is prepared by using a technique called wet casting method. In this, the two polymers CMC pectin were dissolved in a distilled water, and then to this glycerol is added. After the complete dissolution, by the process of stirring, we are adding this silver nanoparticles, which is prepared by green synthesis method, and then everything has been stirred, and then calcium chloride is added to it. After that, the solution is subjected to vacuum pump so that to remove the micro bubbles which are present in it. After that, it is kept for drying under the UV light or IR light. Later, after the drying, we can prepare a neat CMC silver film which is prepared by wet casting method. This is the method of preparation. Next slide, ma'am. So coming to the result and discussion in brief, so we can see that UV visible spectral analysis, this is nothing but the silver nanoparticle characterization. So here we can see there is an absorption peak observed at 419 nanometer, which confirms there is a presence of silver nanoparticles. And also here we can see the color test also. Color changes from colorless to brown, which indicates there is a reduction of silver nitrate to silver nanoparticles. Next slide, ma'am. So coming to SEM analysis. So SEM, scanning electron microscopy. Here if we see there are two images are present. The first image is of nothing but CMC pectin film. So CMC pectin film without the presence of any nanoparticles. Whereas the next image is CMC pectin with the presence of silver nanoparticles. So we can see the difference, whereas the first picture is very clear and the other one we have the images of silver nanoparticles. Next slide, ma'am. So coming to the antimicrobial activity, the main function. So the main thing, the application of this bio-nanocomposite film is food packaging. So we know for food packaging, we have to see that food should not be spoiled and its shelf life should be increased. So for that, first thing we have to see is its antimicrobial activity. So antimicrobial activity, if we see here, after the addition of the silver nanoparticle into the biopolymers, we can see there is an increase in the activity. So if it is increased, we can use it for the application of the food packaging. And also it also has main barrier properties because of presence of pectin and CMC. So next one, ma'am. So coming to the conclusion part, so we can conclude that this is a green synthesis eco-friendly method for the preparation of silver nanoparticles by using sodium gujava leaf extract, that is without the usage of any chemicals. So and it is comparatively eco-friendly method compared to physical and chemical process. Next, coming to the biofunctional nanocomposite, it is prepared by incorporating silver nanoparticles with the blends of CMC and pectin, and its characterization were also studied. Because of this, we can say that we can recommend that it has good antimicrobial, antibacterial function. So it is potential to be used as an active food packaging film. So this is about my presentation, ma'am.
Yes. Can I ask one question?
Sure.
Madam, how can you detect whether it is a silver nanoparticle or silver nanowire rod, etc., from UV spectroscopy?
Sir, from UV, we can just determine whether it is silver particle, there is a presence of silver or not. So it is characterized by using silver particle size analyzer, zeta potential analysis. We can assume that silver nanoparticles are formed by seeing the sizes.
No, I am not asking about other instruments. I am just
Okay.
from plasmonic modes. How can we detect it? It is either in spherical shape or in wire shapes.
Spherical, sir.
Yes, nanoparticle is in spherical shape. I know that, and the rod is the epithelial modes. But how can you detect? How can you judge? It is the particles that form. We are synthesized through different various methods. Whether it is particles or is in wire shape. What is the exact routes to detect?
Sorry, sir, I don't know.
Yes, yes. Thank you.
I have a question regarding the optical absorption. Your absorption y-axis almost reached 4 value, absorption value 4. So how you make that kind of experiment? Your particle is completely black or a different kind of color?
Sir, it is brown, sir, reddish brown in color.
I think you detected the. I think you take the spectrum like a saturated spectrum because of the optical absorption y-axis value 1 means 90% of lights were observed. So if it is 2 means 99.9% light were observed. So your absorption value is 4. So how can you say this is a good spectrum? See, even the 420 or 430 nanometer also reached 3, absorption value 3. That means almost nothing, nothing light is passing through your sample. That means you are detecting, so you are saturating the detector. Then it's not the real value of your particles. Maybe you can reduce the concentration, you can see the plasmonic modes. It's related to the previous question.
Okay, sir.
So please careful to measurement because of it's completely wide the optics.
Okay,
Lambert's
sure,
law.
sir. Okay.
Yes, to add to that, Dr. Saugandhi, it will be linear. The Beer-Lambert's law will be mostly obeyed if the absorbance is less than 1. So you should bring down the concentration to that level.
Okay, ma'am. Thank you for your.
Okay, thank you for your suggestions. Dr. Sugandhi, I request you to please see this. Okay, and thank you for your presentation.
Thank you.
Thank you.
Thank you, ma'am.
Okay, so can we go next, sir? Nagaraj, sir? Can we go next for that? Dr. Miss Uma Maheshwari. I request Mrs. Uma Maheshwari to present her work.
Yes, madam.
I request Mrs. G.T. Uma Maheshwari to present her work.
Sorry, unmute yourself. Unmute, Madam Uma Maheshwari.
Yes, sir. Yes, sir.
Yeah, present, madam.
Yes. Good morning, all of you. I'm Mrs. G.T. Uma Maheshwari. I'm working as a guest lecturer in Aringarana Government Arts College, Attu, and also I'm a part-time research scholar in Periyar University. Thank you for this wonderful opportunity to present my general view of in air pollution. And coming to my topic, one slide. My abstract is it is just a general introduction about the air pollution and the effect of introducing the nanomaterials into the air pollution, and what are all the positive effective measures that could be taken for the clean environment. Actually, this the nanotechnology field has been developed in a wide variety, and I feel it is the necessary for the researchers as well as the educationalists to focus these nanomaterials and create awareness among the common people for the remediation of the air pollution. And next slide, ma'am. And these are just the nano world. What are all the nanomaterials? And nano view of the mosquito bite or a drop of water and some nanoparticles. And by use of this nanotechnology, it becomes more necessary for us to make our environment in a pollution free. And next slide, ma'am. So what are all the impacts of air pollution on environment? Besides the water pollution as well as the soil pollution, the air pollution creates a very core impact on the human beings as well as the living creatures, because the air which we take in, when it becomes polluted, our total life becomes collapsed. And according to the World Health Organization, every year 1.5 million people are suffering from chronic respiratory diseases as well as asthma. So the awareness should be created among the common people so that they don't get affected by these kinds of respiratory diseases, and they becomes peaceful living. And in November 2017, by the Great Smog in Delhi, an accident has taken place. Because of this low visibility, 24 vehicles were affected and a major accident took place. All these are because of the air pollution and unawareness among the common people as well as the government sectors and the public welfares. Next slide, ma'am. And my objective towards this topic is simple. Which kind of life we would like to live in. The image which I have depicted shows, one image shows the clean environment and one is the corrupted world. So it becomes it is a core problem which we are facing today, and we have to take certain steps and see the health effects which is being faced by the human beings, and what are all the variety of problems which we are facing. The major thing is that the burnt wastes, in variety of places, the burnt wastes creates a lot of air pollution, and it becomes a necessary to control all these things for the air pollution free environment. Next ma'am. So the nanotechnology, it becomes the answer for this air pollution, and it is the best method and the more important method for the clean environment, because the nano catalysts have the increased more surface area for the gaseous reactions. So this catalyst, what they do is they transforms the harmful vapors from the cars as well as the industrial plants into harmless gases. So the harmless can be converted into harmless by more utilization of this nanotechnology. Gold nanoparticles, they convert the highly toxic carbon monoxide into carbon dioxide. So by use of these nanoparticles, the air pollution can be made into our control. Next slide, ma'am. And this single-walled carbon nanotubes, this is for the large-scale utilization, because the carbon nanotubes have abundant pores and large surface to volume ratio and strong absorption and desorption capabilities for gases. For that, their purification becomes more easy. Next, ma'am. And this picture depicts the bulk materials, the bulk material surface area and the nanomaterial surface area. When coming to the nanomaterials, we find the increased surface area so that the the toxic materials can be easily taken out from the gaseous combusted gaseous particles. Next, ma'am. And the carbon nanotechnology, it is for the large scale. The use of carbon nanotechnology is for the large scale, because it is working for it can trap the gases up to 100 times faster than the other methods, allowing the integration of large scale industrial plants and power stations. So carbon nanotechnology, carbon nanotubes based technology, it is for the remediation and the purification of large volumes of gases. Next, ma'am. And the recent technology, nanotechnology evolution, is the carbon nanotubes as well as the carbon nanohorns. The diagram which I have depicted here, the diagram itself includes the more pores which is being visible in that carbon nanohorns. that increase the surface area, and particularly these silica titania nanocomposites are being utilized for the removal of the mercury vapors. So this nano horns should be more utilized for the air pollution free environment. Next, ma'am. My entire question is that what kind of environment we would like to give, because the clean environment is in the right side, and the left side, both the human beings as well as the environment as well as the entire world becomes polluted by means of this air pollution. And what I would like to explain is that we have to create more awareness programs among the common people, so that not the researchers will entirely know the depthness and the impact of the pollution, but the common people are unaware of the effects and the hazardous future conditions. So it becomes necessary for the government sectors as well as the private sectors to conduct more awareness campaigns and do more research works in this air pollution by use of the nanotechnology, so that we can live in a clean environment. Thank you.
Floor is open for questions. I ask audience, please ask questions. I request audience, please ask your queries.
Regarding your carbon nanotube or carbon nanohorn, is the chirality dependent usage in your environmental application, or they have chirality dependent issue or not? My question is,
Sir, I'm hearing, sir.
Okay, your nanomaterial is chirality dependent or not? That means you know, the single wall carbon nanotube have the left-handed, right-handed chirality nature.
Sir, actually,
so nanomaterials are capable of working with the both chirality.
Okay, so I can conclude that okay, there is no experimental data. So I think that these are all the literature surveys. So please skip this. Yeah.
Okay.
So we can go ahead with the next speaker. Yeah.
Yeah, this is only, I think, literature only. Okay.
Yes,
no
yes,
problem.
yes. Yeah. So please go ahead with the next speaker.
Okay. Please.
Thank you.
Thank you. So this, I request the next speaker, Dr. Anubhuti Avasthi.
Anubhuti Mishra,
Please present your work.
Okay.
I request Dr. Anubhuti Avasthi, please present your work.
Myself, Anubhuti Avasthi, and my research topic is redox used for assisted transport of neutral molecules through liquid membrane technology. On next slide. Next slide. Next slide. Yeah. This is the abstract. We have synthesized redox fused ionophore like lariat ethers, single arm rays, and double arm. And these redox fused lariat ethers were used in liquid membrane carrier facilitated transport of alkali and alkaline earth metal and glucose molecules. And effect of cellulose nitrate membrane and axial membrane used as a membrane support. And ionophore M1 is selective for sodium, lithium, and potassium. And ionophore M2 and M6 are selective for lithium, sodium. And all ionophore means ionophore M1 to M4 shows selectivity for glucose molecule, and this can be used in the fabrication of redox switchable devices and biosensors. Next slide, ma'am. This is supramolecular chemistry. Everyone knows supramolecular chemistry is the subject of association of the two or more chemical species held together by intermolecular forces such as electrostatic interactions, hydrogen bondings, van der Waals forces, which could lead to organized entities of higher complexity. It is one of the fastest growing discipline, crossing a range of subjects from biological chemistry to material science, and shows greater potentials in the field of catalysis, drug delivery, biotherapy, electrochemical sensors, self-healing materials. Next slides, ma'am. On the literature, on the basis of topology, ionophore can be classified into podents, crown ethers, and armed macrocycles. Podents like acyclic, crown ethers like cyclic, and armed macrocycle, it means acyclic plus cyclic. And we have synthesized this type of redox Swiss lariat ethers like single arm, braced, and double arm lariat ethers. Everyone knows natural ionophore like valinomycin and cryptans and crown ethers, and they are selective for potassium due to non-covalent interactions. Ma'am, next slides. This work done in the field, a research area in supramolecular chemistry that has received interesting interest involves in spontaneous formation of a well-defined supramolecular structure, like altering the structure of receptors. And in the field of redox switching ionophores, Ikigoyen and Echeverrias, they reported the first example of cation transport in both activation and deactivation of ionophores has been carried out electrochemically. Next slide, ma'am. Next slide, ma'am. Yeah, this is experimental lab. We have a series of redox Swiss ionophore. This is 1-chloroanthraquinone interact with different glycol series like tetraethylene, triethylene, diethylene glycol, and diethylene glycol monobutyl monomethyl ethers in the presence of sodium hydride THF under nitrogen atmosphere and product of form. These products can be confirmed by spectral analysis, and this paper is published in Separation Science and Technology. And this apparatus is used for supported liquid membrane transport studies. This is two half cylindrical cells. One cell contains source phase, another is a receiving phase. Between both of them, this is a supported liquid membrane, and different types of redox switch receptors impregnated with cellulose nitrate membrane or axial membrane, and used as a membrane support. And this is the result amount of metal ion transported in by using cellulose nitrate membrane. So ionophore M1 is selective for sodium and potassium, and ionophore M6 is selective for lithium because of due to ionophore chain, means anthraquinone form a pseudo cavity. Next slide, ma'am. Yeah. This is the amount of metal ion transported by using axial membrane. So axial membrane ionophore M1 is selective for calcium, and ionophore M6 is selective for both. Means next slide, ma'am. This is the amount of glucose transported after 24 hours with ionophore in supported liquid membrane. This is two membranes like axial membrane and cellulose nitrate membrane. Between both membrane, ionophore axial membrane is a better membrane support as compared to cellulose nitrate membrane. And all ionophore means M1 to M6 shows a higher transportability to glucose. And this is the axial membrane before transport and axial membrane after transport with glucose. And this is the cellulose nitrate membrane before transport and after transport. And this shows the hydrophobicity, and metal ion transports mainly depend on the structure of ionophores like number of donor sites, flexibility of chain length, ionophore concentration, and also the concentration, charge density, and size of metal ion. And this can be used in the fabrication of redox switchable devices, molecular wires, and chemical sensor. And cellulose nitrate membrane is a better support as compared to axial membrane in case of alkali-alkaline earth metal cations, and neutral molecule like glucose is better transported as compared to main group metal ion. And electron microscopy studies are also supporting SLM studies. Thank you.
Thank you, Dr. Anubhuti, for your presentation. And now the floor is open for queries or questions from audience.
Yeah, Dr. Anubhuti, I have a question. You have any reason for the selectivity? You said axial membrane shows selectivity towards one, and the other one shows towards the other.
Axial membrane is a natural membrane and is selective for glucose only, not the alkali and alkaline earth metal cation. Alkali and alkaline earth metal cation is selective for only cellulose nitrate membrane, not axial membrane.
Okay. So you mean
how did you?
Sodium,
one
potassium, and
question,
calcium
Doctor.
are extracted through that, or it is selective?
Yeah, ma'am. Yes, selective, ma'am.
Okay.
I have a question. After like doing that liquid membrane, how did you characterize ki how much metal is transported or not? Matlab which method? You have shown
Ma'am,
one
it's a supported liquid membrane. Yeah, supported liquid membrane transport studies, ma'am.
Means how much metal is transported. So you have to do some
Blank
characterization.
experiment.
Blank, yeah.
Yeah, ma'am.
So
CVS
which
study,
like
ma'am. CVS study also confirmed the transport. Yes, sorry, ma'am.
matlab from how much metal for how much time it is transported? Did you check by any
Yeah,
atomic
24 hours,
absorption?
ma'am. Yeah, ma'am. I'll check 24 hours, 48 hours, 72 hours. So better transport
By
in
which
48 hours.
method did you check? By which method did you check?
Ma'am, supported
Like
liquid
atomic.
membrane transport studies.
No,
Yeah.
Dr. Anjali, she is asking the spectroscopic method that you are using.
Yeah,
to
no.
check the method.
Glucose, ma'am. Glucose is spectrophotometric method, and
Yeah,
the
that's
active
what
and
I'm
alkaline
asking.
earth metal atomic absorption spectroscopy method.
Wait, that's what atomic absorption spectroscopy. Did you check?
Yeah,
Yes.
atomic absorption. Yeah.
Okay.
And
one more thing,
glucose,
is it a
ma'am,
continuous process
spectrophotometer.
or it is a batch process?
Ma'am,
Yes.
it's a continuous process.
Thank you.
Yeah.
Okay. Yeah. Any other questions from audience? Okay. Then we thank Dr. Anubhuti for her nice presentation. Thank you.
Thank you.
Now can we ask next Sujit Gopal Roy? Or this second is next 7th one is not there.
Yes, madam.
Dr. Nagaraj.
Yes, yes, ma'am.
Okay.
You can go ahead to 22.
Next, okay. I welcome Dr. Vishwajit Gopal Roy to present his work.
Okay, thank you, ma'am. And I want to thank the organizer for giving me this opportunity. So today I'll be discussing about I'll restrict my talk to the acridines and acridinium science synthesis actually. So, yes. So actually here we want to present a environmentally benign synthetic approach. So far, all the synthesis of acridine is done on the suitably substituted p-functionalized aromatic precursors. So we have synthesized the acridines and acridinium ions. It's a general synthesis we have done, and it is commercially available starting material from commercially available starting material and all aliphatic precursors. And in that, what we did, we have used the multi-component reaction and novel efficiently catalyzed dehydrogenation reaction for the synthesis. And as it is ligand-free approach and use the iron as the catalyst, so and to use the molecular oxygen as the terminal oxidant and produce water only the byproduct. So it is a very green approach for the synthesis of acridines and acridinium. Next slide. So as we know that acridines are one of the earliest known very useful class of compounds. Many of them are FDA approved drugs, as you can see over here, and some of them are now in blockbuster list. And acridine orange, we know it is used as the fluorescence probe. And in 2004, Fukuzumi has developed this molecule as the photoredox catalyst. And after that, large number of organic synthesis came using this as the photoredox catalyst. So these are very useful class of compounds. Next slide, please. So as it is a very useful class of earliest known compound, so large number of synthesis has came to the field. The first one is as early as 1884 by Brentzen. And after that, many syntheses came. I have listed only a few. So these are all acridine synthesis, and this is acridinium ion synthesis. If we look at all those things, what we can see is that the prime requirement is the suitably pre-functionalized aromatic system. Suitably pre-functionalized aromatic system is the prime requirement. And second requirement for acridine is either toxic heavy metal ligand complex or the expensive heavy metal ligand complex, or very highly reactive precursors. And in case of, go back please. The acridinium ion, in case of acridinium ions also, you can see suitably pre-functionalized the aromatic system is the requirement, and on top of that either strongly acidic or strongly basic condition is needed. So basically, as we know that the suitably pre-functionalized aromatic systems are very hard to prepare, and most of them are not commercially available. So this itself takes large number of steps, and this increase the energy cost and labor, everything is there. So we wanted to develop a method where we can use the commercially readily available material and make the acridines from there. Next slide, please. So for that, we targeted this molecule. This is easily prepared from the multi-component reaction. Just you take the aldehyde and amines and diketones. Within 15 minutes, half an hour, it's easily formed as a solid. And just we have to precipitate, we have to filter it out, and pure compound is there. Then there is a method where actually large number of methods, not large, several methods are there to make this the pyridinium or pyridine rings. But there is not a single method which can make this molecule to this one. Actually, there needs the aromatization of this peripheral cyclohexanone ring. So in acridine case, we have not found it. When we search, next please. When we searched the literature, we found that Stahl group published several papers, 3 papers actually. What they did is they means oxidized dehydrogenative oxidation they have done on cyclohexane or cyclohexene using the palladium and palladium complex and oxygen. So there is a possibility that we can do it, but we didn't wanted to use the palladium heavy metal or the ligand complex with it. So we wanted to use something environmentally friendly. So next slide, please. So we have developed a method where we have used the multi-component reactions to get this one, and after that we use the FeCl3 and microwave condition and alcohols we have used to get this acridine moiety. And this the good thing is that if we use the sequential addition, means first allow 15 minutes for this one, and in one pot we use FeCl3, then also you can get this one. Obviously, little bit of less yield will be there, because here you are taking the pure compound of this one. So some of the little less product in one pot method will get. Okay, next slide, please. So using this method, we have synthesized large number of substrate scope. To explore the substrate scope, we have synthesized many acridines. As you can see, from the electron donating, electron withdrawing, everything is there. But what we found is when we are using the electron donating group, the electron the reaction is sluggish, and it's tend to give lower yield compared to the electron withdrawing groups. So actually this also give us some clue for our mechanism, which will I will discuss a little later. No, please back please. Yes, when we use the alcohol, different alcohol as the solvent, so the alcohol get incorporated into the system. So here ethanol, initially methanol, then ethanol, propanol, and butanol, so all got incorporated into the system, and that doesn't change much yield. But when there is a substitution, actually yields also increase in the diketone. Substitution is in diketone, also the yield increase the yield. Next slide, please. So after the aldehydes and then we changed the diketones. We have taken several substituted diketones, and we found that the increase in the yield found. And after all these diketones also, one more thing left is amine, change of amine. We have tried to change the amine also, and when we change the amine, the acridinium ions also form. So far there were not a single method which could make acridins and acridinium ions, but this method can make it. Okay, next slide, please. To optimize the reaction and to prove the mechanism, actually we have done multiple controlled reactions using different concentration of FeCl3, and in conventional method actually up to we varied the hours, and we found this type of curve where it says that first the formation of this takes place, and after that it's gradually with the incorporation of methanol, it gradually aromatizes. So first one side, then two sides, and when we increase the FeCl3 further, then what happens? A little amount of chloroproducts also found. And what we found that when we don't use when you use one equivalent of FeCl3 in conventional method, if we don't use oxygen, it doesn't never goes to completion. And with tempo, only tempo without FeCl3 doesn't work. So the oxygen and FeCl3 is the minimum criteria we have to give for the reaction. Next slide, please. So on all the controlled reactions and whatever yield we got in the different stages of the reaction, from that we have proposed this mechanism. And first is the formation of this one that is reported already, or as I told already. But next is this one. This one happens with the attack of methanol in presence of FeCl3. That's why, and this is the rate determining step. Actually, means we have never found a compound like this, or any compound got aromatized where the OMe didn't get incorporated. So we can tell that this is the rate determining step. And as it is happening in presence of FeCl3, basically we thought that the FeCl3 acting as the Lewis acid. And once this happens, after that, the aromatization takes place. Next slide, please. Now you can understand that when the electron donating groups are there in this place, what happens now? This electrophilicity of this carbonyl actually reduced. So attack of methanol becomes difficult. So that's why it becomes lower. And when NO2 is there, it's become facilitated and it gets higher. And when phenyl group is in the diketone, actually this intermediate gets stabilized. So little higher yield we are getting. Next slide, please. So what we have developed a Grignard method for synthesis of acridins and acridinium ion. It doesn't require suitably pre-functionalized aromatic systems. It's exploit high atom economy and diversity of multi-component reaction to merge with novel FeCl3 catalyzed oxidative dehydrogenation reactions. And it's a ligand-free approach, used environmentally benign iron is the catalyst. And the method used aerobic oxygen as the terminal oxidant, produced water as the only byproduct. Being modular, so these diverse structural features we can change and modulate the features like medicinal or photocatalytic or photovoltaic properties we can change of the material. And using the acridinium catalyst, we have actually done multiple organic synthetic reactions. But here we cannot present that one due to the time limit. Thank you. If you have any questions, I'll be happy to answer that.
Thank you, Dr. Vishwadev Gopal Rai, for your nice presentation and nice work also. I request now audience to ask any queries.
Thank you, Dr. Roy. It's a nice work, actually. I have a question. Sir, is it NMR yields or GCMS yields?
Actually, all those yields are isolated yield. All those yields are isolated yield, and it is done in microwave conditions. In when we for the purpose, for the mechanistic study purpose, we when we are doing in the conventional method, that time we did HPLC study with the reactions, and in that case we have not isolated. But whatever yield I have presented over here, all those are isolated yield from the microwave reactions.
Okay.
Which microwave did you use? Domestic or commercial?
No,
Like,
it's a CM corporation.
Okay. Good.
Thank you.
Any other question, please? Okay, nice piece of work, Dr. Roy. So we thank you for your nice presentation. Thank you. Thanks, Vanan. Okay, shall I, Dr. Nagaraju, shall I go for next?
Yes, ma'am, you can proceed.
Okay. Thank you. I request Dr. Ahmed Hussein bin Mohammed, please present your work.
Okay, thank you to moderator. Okay, so my name is Ahmad Husseini Mohammed from Malaysia. So my paper's project entitled Synthesis and Characterization of Magnetite Coated Carboxymethyl Nanofibril from Oil Palm M3 Fruit Bunch Residue. Next. Okay, so the abstract is, this study is to explore the surface functionalization of cellulose nanofibril derived from the oil palm empty fruit bunch. So the magnetite coated carboxymethyl cellulose nanofibril from carboxymethylated CNF was successfully synthesized from the cellulosic material of oil palm empty fruit bunch biomass, and magnetite was coated using sodium technique. So the chemical and physical property of the magnetic carboxymethyl cellulose nanofibril was characterized using IR, SAM, TEM, XRD, TGA, and BET analysis. So characterization results show that hydroxyl group on the cellulose nanofibril surface was successfully modified by the carboxymethyl group, and then before coated with ferrum oxide. So it was observed non-uniform growth of the carboxymethyl cellulose nanofibril coated with the spherical pattern of the ferrum oxide were observed through SAM and TEM. XRD results show the disappearance of cellulose type 1 peak and appearance of the 6 new peak corresponding to the crystalline ferrum oxide. BET analysis showed low surface area due to the self-aggregation from the freeze drying activity, and the produced magnetic CMCNF is easily collected via external magnetic, assure that recovery during absorption activity. Next. Okay, so introduction. Cellulose nanofibril was extracted from the oil palm empty fruit bunch, which is obtained from the oil palm industry, and then this isolated cellulose nanofibril contain alpha anhydrous glucose, which is linked by the beta-1,4 glycosidic bond, and then it will form an inter and intramolecular hydrogen bonding between the structure. Next. So in this study, OPEFB will be prepared and then extracted by pre-treatment process using sodium hydroxide, and then bleaching using the sodium hypochlorite before undergo chemomechanical process to form cellulose nanofibril. And then it will undergo carboxyl methylation, which is divided into two parts, which is mercurization and deetherification, produce the carboxymethyl cellulose nanofibril, which is we replace the structure with the carboxymethyl group at the C6 of the carbon, at the carbon cellulose. And then we coat it using solder, using ferrum oxide, using solder technique. Next. So for the literature review, the main concern of the cellulose nanofibril surface functionalization was done to overcome the shortcoming, which is high tendency of the self-aggregation caused by the presence of hydroxyl group on the hydroxyl group during formation of inter and intramolecular hydrogen bonding. And then carboxymethylation was the solution, which is this process involved mercurization and etherification, which is replace hydroxyl group with the carboxymethyl group, and then it will cause a negative charge on the surface. Soldier reaction involves two steps that are hydrolysis and precursor followed by the formation of gel via water or alcohol during polycondensation reaction. So the technique offers the simplest and convenient process with many advantages towards the activity of absorption. Next. So this objective of the research is to synthesize and characterize method for the development of magnetite-coated carboxymethyl cellulose nanofibril. Is first to isolate the cellulose nanofibril from the oil palm anti-fruit punch using alkaline medium, which is sodium hydroxide, assisted with the homogenization and sonication. So secondly is to perform the functionalization using carboxymethylation step, followed by the introducing magnetic ferromoxide using Soja reaction technique. And lastly is to characterize using several instruments such as IR, BET, SAM, TEM, XRD, and GA. Next, this is the experimental method which I divided into three types, which is step one is the extraction of cellulose, which is the raw OPFB will undergo process of pretreatment, and then it will produce cellulose. The product obtained is cellulose, and then it will undergo process of isolation to produce cellulose nanofibril, which was done using the alkaline solution, sodium hydroxide, and then at the same time, we use homogenizer and sonicate. Next, we move to the synthesis of magnetite carboxymethyl nanocellulose, which is we use carboxymethylation and then followed by the Soja technique. Next. Okay, so result one show that the raw OPFB fiber after bleaching and pre-treatment using sodium hydroxide and the sodium hypochlorite, it was shown that the color turned from brown to grayish light color, and the FTIR shown that from the raw OPFB, the peak at the 1,700 and 1,200, 240 represent for the hemicellulose and lignin was disappeared after isolation of cellulose nanofibril. And then during introduction of the carboxymethyl group, it was observed that the carboxymethyl group peak was observed at the 1,600 approximately, which is indicate the introduction of the carboxymethylated group. Next. Okay, for the SAM and TEM result, it was shown that the structure of this cellulose nanofibril was irregular, non-uniform, and then after introduction of the carboxymethyl, the structure become rough, okay, due to the introduction of the carboxymethyl group, and then it was not altered, and the structure was almost the same after we introduced the ferromoxide. However, in TEM, we closely observed that the structure of the carboxyl cellulose nanofibril, the structure diameter is less than 100 nanometer, which is comply with the term of the nanoparticles. And then due to the agglomeration between the structure, it will become the flaky type of the structure. And for introduction of magnetic type, it was observed that black area covered the cellulose structure, carboxymethyl cellulose structure, showing that the coated was successfully done. For the BET, it was observed that due to the BET surface area was decreased due to the freeze drying activity, which is it combined and makes the structure become more interact towards each other, and then it will become agglomerate. Next. The result for the XRD is shown that the structure for the CNF, the crystallinity index is 76%, and it showed that the structure is a cellulose type 1 representation, and also similar for the native plant. And then for the carboxymethyl nanocellulose, which is second part, it was observed that the combination of these two peaks was diminished, and then it formed another type of peak, which is represent more towards amorphous type. And then for the introduction of the ferrum oxide, it was observed that 6 new types of ferrum oxide peak was observed, contribute to the crystal plane from the peroxide, and it diminish all the plane from the cellulose. And lastly, from the TGA, before that, from the TGA, it was observed that the stability, thermal stability increased from for the magnetite cellulose nanofibrils, showing that the compound was high thermal stability and with the residue at 80-100 degree more than 45%. Next. In conclusion, we have successfully synthesized eco-friendly magnetite-coated carboxymethyl cellulose nanofibril using carboxymethylation followed by the soldier technique. And here, cellulose nanofibril was obtained from oil palm biomass, which is agricultural waste, and the sustainable material due to its abundant generation and inexpensive cost. Okay, so the prepared material can be seen as a promising for future absorbent candidate due to the being simple, economical, eco-friendly to prepare, and being practical for large scale. So the magnetic introduced was separable and reusable in absorption process and separation. Thank you.
Thank you, Dr. Ahmed, for your nice presentation and nice work also. So it will be used for the large scale also, I think. It can be used.
Yes.
Yes, no? So that is more useful, only not for paper publication. If we can use in the better way, that will be, I think, more useful for the today's environment. This now the floor is open for the questions from the audience. You can ask your queries. Audience, you can ask your queries to Dr. Ahmed. So if there is no question, so we can move to the next presenter, next presentation. So I invite Dr. Kaviraj Kaviraja P. Sambal Sevam to present his work.
Okay, thank you, and good morning to everyone. So first of all, thank you to GITAM University for giving this opportunity. I am Dr. Kaviraja from University Technology Mara, Malaysia. The title that I'm going to present today is Optimization of Waste Coil Eggshells as Biocomposite for Polyaniline and Ammonia Gas Detection. So basically, this study was conducted by my student. Okay, so this is a simple, cost-effective, and novel chemical sensor for ammonia gas detection. And we use the material polyaniline coil eggshells. So far in the literature, these two things integration has never been reported before. So that's why we call this as a novel material. And then to prove the integration of these two materials together, we have carried out several characterization, including FTIR, UVVs, SEM, EDX, TGA, and etc. And finally, we have conducted a simple chemical sensor. Is my line okay? Clear? Is it clear?
I request other participant, please mute yourself. I request other participant, please mute yourself. Okay, thank you.
Okay, so next slide. So as for the introduction, ammonia is already found a widespread usage worldwide, but at the same time, it also possesses certain degree of toxicity. It can be harmful to the environment and also to the human health. And so in this study, we actually, why we use the coil eggshells, because eggshells is something that will be discarded and it will be ended up at the landfill. So we don't want to waste just like that the material. We wanted to make use of those calcium carbonate rich shells and then integrate it with the polyaniline, so that we just wanted to see whether it can perform well in the ammonia gas detection or not. So next slide. Okay, as I mentioned earlier, ammonia is a toxic gas, and the threshold value for the ammonia exposure is 25 ppm. And on the other hand, if we look at the polyaniline, this is one of the conducting polymer, and it has excellent properties. However, it has some low mechanical strength, and also it has a poor processability. So to overcome this problem, it often will be integrated with the fillers, inorganic fillers. So in this study, we wanted to make use of a waste material as a filler. And then we wanted to see whether it can enhance the sensing properties of the polyaniline or not. So next slide. Next slide, please. Okay. So simply the objective is to synthesize and prepare this material and also to characterize them. And finally, we wanted to test as a sensor. But the ultimate goal is to make use of the waste material and see whether the polyaniline can perform better in terms of the sensing or not. So next slide. For the experimental part sample preparation, so the shells were first washed and then dried. After that, we ground it, and then we also did some sieving. And then the synthesis of pristine penny, we carried out via chemical oxidative method, where we used the oxidant and also we used the dopant at the final stage so that it can become uniformly doped. And we got a green color solution that we coated on a glass substrate. Next slide. So for the preparation of the composite material, we have carried out an ex situ, which means the polyaniline already prepared, and then we just physically add the eggshells, and then we blend it. After that, we have prepared a few ratios as shown in the table. For the sensor measurement part, we have used the multimeter, and then we used the formula as shown in the slide there. And also we carried out few sensing of sensor properties measurements. Next slide. Okay, so results and discussion for the FTIR. So we all know that this is one of the very good fingerprint technique to identify the important functional groups, whether present again in the composite material or not. So as overall, all the functional groups that belongs to the pristine penny, which means the pure penny, and also the eggshells, all present in the composite material, with slight increase in terms of their wave number. So it is one of the proof where it shows that there are some kind of chemical interaction between these two materials, which is polyaniline and also the eggshells. Next slide. Okay, so figure 2 UVV. So here we can just focus on the 700 to 800 nanometer, the absorbance peak there. So basically that peak is pi to polaron, which indicates the amount of charge carriers that will be possessed by the polyaniline backbone. And the higher the charge carriers, the higher the conductivity will be, as shown in the figure 3. As you can see in the figure 3 line graph, the penny QES1, which means the ratio is 1:1 between this penny and also the QS. Basically, it recorded the highest conductivity in our study, and also it performed the best in terms of the sensor measurement. Next slide. So this one XRD, just to see whether there is any crystallinity changes or not. So as we expected, the penny is a polymer, so it typically exhibited amorphous nature. But after we have added in the coil eggshells, we can see certain degree of crystallinity in terms of the composite material, which also facilitated in terms of its conductivity properties. So next slide. Okay, so here we have, for the morphology part, we have carried out a SEM mapping and also the EDX. So SEM for the A, the pristine penny, it basically showed, it showed the fibrillar structure. For the B coil eggshell, it showed a rough morphology, but the highlighting part over here is the D, where the equimolar ratio between polyaniline and coil eggshells, where it exhibited certain degree of porosity, which actually facilitates the adsorption of ammonia gas into the polymer matrix so that it can perform the best in terms of the sensor measurement. And also the mapping, if we can zoom and see, you can see a lot of dots for the calciums, which indicates that the mapping and also the EDX is further proves the integration of this polyaniline and also the coil eggshells. Basically, from coil eggshells, we are focusing on the calcium carbonates. So they have complemented each other. Next slide. Okay, for the thermal stabilities, obviously QS performed the highest thermal stability because of the inorganic substituent. But interestingly, compared to the pristine penny, the composite materials exhibited slightly higher thermal stability. So it shows that they have certain degree of higher thermal stability compared to the pristine penny in the study. Okay, next slide. So about sensor measurement. So we have started this work with the calibration plot. So we have tested the calibration for all the pristine penny and also the composite material. And as you can see here, the penny QS1, it exhibited the highest linearity and also the correlation coefficient of 0.9932. And then also it recorded the lowest limit of detection, which is 5.24 ppm. So that's why we selected only this polymer, this composite, to carry out the other sensing properties. Next slide. Okay, for the selectivity, we have tested with some common interfering gases, and we realized that it showed higher selectivity for the ammonia, probably because of the ion dipole interaction between penny composite and also the ammonia. Next slide. For the reusability, we have conducted for 10 cycles, and it showed that for up to 4 cycles, it is kind of stable. But after that, probably because of a continuous dedoping and redoping, it denatured, or it's like the reactive parts are blocked away. Next slide. This is a comparison of a few other sensors, penny-related sensors for the ammonia gas detection, and we got the present work is 5.24 ppm. Obviously, this is not the lowest limit of detection, but we have got the ideal one because the threshold value for the ammonia detection is 25 ppm. In addition to that, none of the sensors actually emphasize on the usage of waste materials in the preparation of the polyaniline sensors. So in this study, we have successfully used the waste material to enhance the properties as well. Next slide. Figure 10a basically shows the mechanism where the polymer that we synthesize is a green color, and then when we let it to react with the ammonia, it will be turned into blue color. The film will turn into blue color. That is another observation, optical observation. And the figure 10b, the figure at the top actually shows the optimum amount of eggshells at the penny matrix, but at the figure 10b bottom one, it shows too much of for that one is for the penny QS2, where too much of eggshells, they agglomerate and then they block the proper conductive pathway and also the reactive sites. Next slide. Okay, next slide. Okay, in conclusion, we have successfully synthesized, prepared this composite material, and also it has the potential to work as a potential ammonia gas sensor. And also we have tried to achieve this one of the SDG goal, number 12, responsible consumption production, where we are focusing on the zero waste energy. Next. This work already published, just recently published in October at the Polymer Engineering and Science by Wiley Online Library. So the DOI is given. If you're interested, you can read the full paper. Next slide. Okay, so this is my business card. If you have any question in future, you can ask me, or any future collaboration also can contact me. Thank you again.
Thank you, Dr. Kaviraj, for your nice presentation. Your material is also well characterized. I am happy to see your all work. Now the floor is open for questions from audience.
Yes, this is Dr. Ramana from GITAM, Bengaluru. Yes, sir.
Yes,
that you have used the ammonia, right?
Yes, doctor.
Ammonia that is liquid or gas, sir?
It was initially in the liquid, but we have used it's a homemade chamber kind of a thing where we have placed the ammonia on the hot plate and then we heat it up at the 50 degrees Celsius so that it can create the vapor. Yes. And each time we have used a different concentration of ammonia.
Thank you, sir. Thank you very much. Because recently I've done some another work. I got some question from the reviewer point of view. That's why I raised that question. Yeah. Thank you very much. Thank you.
You're welcome.
Okay, madam, it's fine.
Okay. Okay then. Any other person wants to ask something? Okay then. Thank you, Dr. Kaviraj, for your nice work.
Thank you once again for the opportunity.
Okay. So now we'll go to the next presentation. I request Dr. Sheikh Ahmed to present his work. Dr. Sheikh Ahmed, please present your work.
Okay, thank you very much. So hi everybody, my name is Dr. Sheikh Ahmad Izzuddin Sheikh Muhammad Ghazali, and I am from UiTM. I am from University Teknologi Mara, Negeri Sembilan, Malaysia. So today I will design my work or research entitled Synthesis and Characterization of 4-chlorophenoxyacetic acid herbicide. Actually, 4-CPA is the kind of agrochemical that has been used in agriculture and integrated with calcium aluminum layered double hydroxide for environmental friendly nanohybrid. Next. So ADH is a material that can be used as a spot for control release formulation for herbicides such as 4-CPA in this case. So in this study, calcium aluminum ADH host is prepared as a new herbicide delivery system by integrating the herbicide, which is 4-CPA, inside the calcium aluminum ADH through co-precipitation method. So this synthesis was performed at pH 12 with the mixture of the aluminum nitrate hydrate with uh, with calcium aluminum hexahydrate. And this nanohybrid has been this nanohybrid has been done several analysis, which is PSRD and also FTIR. Actually, we have sent this material for another instrument such as CHNS and also ASAP. But regarding the COVID-19 pandemic, the lab equipment has been closed and our material has been contaminated, and we have to redo our material. Next. So for introduction, for my introduction, as you can see in the on the slide, that the first enemy or the nemesis for agriculture is the weeds. Okay, so this the weeds will be I could say that they will compete between other species that occurs due to the availability of the source of living, such as nutrient and also sunlight, to achieve maximum efficiency. So weeds, which is the unwanted species who live where they are not necessary, because they will give negative effect to our plant. So it will reducing crop yields. It will give a negative effect to our farmers and also to our productivity. And then the increasing number of herbicide will found these days in the results of increases in the number of weed species and introduce significant crop safety and improve weed management. So a good herbicide will possesses a good properties such as effective at low doses, low cost manufacture, and also friendly users. But the most important thing is safe to the environment. Next slide. So guys, this is so everybody, this is what will happen when the farmers use the herbicide on the crops. So from these figures, we could conclude that not 100% of the herbicide will be absorbed by the herbicide. So some of them will be undergo some evaporation process because of the heat, and then some of them will be leaching to the ground water, and this will affected our groundwater. And then the third one, the herbicide will undergo the runoff process, and this will give a very this will give harm to our aquatic living and also our water resources. So to cater to minimize this problem, we have proposed a material, namely as a layered double hydroxide. So the most important properties of layered double hydroxide in this research are environmental capability, especially in agriculture, which are very high uptake capacity. It also have a very high surface area, high anion exchange capacities, and also flexible interlayer space. So next. Then, to the best of our knowledge, only a few studies on this topic has been reported yet, especially on calcium aluminum ADH that integrated with herbicides. Next. So, in this literature review, HCl, or the other name for LDH is hydroxide-like system, has been used in many applications, such as drug storage, delivery agents, and also environmental applications. Next. Next. And also in this research, it shows that 4-CPA is successfully integrated with magnesium aluminum LDH by using co-precipitation method. But for the research, we will use calcium aluminum. So objective of for this research, number one, to synthesis the calcium aluminum LDH host. Number two, to synthesis the calcium aluminum 4-CPA LDH nanocomposite by using co-precipitation method. There are many methods to integrate the herbicide inside the calcium aluminum layer, and one of it is co-precipitation method. This is the very easy to synthesize. The last one is to analyze the characteristic of calcium aluminum LDH host and calcium aluminum 4-CPA LDH nanocomposite by using FTIR and also PSRD. Next. So this is the methods. Number one, we synthesis the calcium aluminum host, and then the number two, we synthesis the calcium aluminum 4-CPA nanocomposite. Next. So to synthesize the calcium aluminum host, okay, we will mix up the aluminum nitrate monohydrate with calcium nitrate hexahydrate. We stir it with by using nitrogen flow. Why nitrogen flow? Because we want to avoid carbonate or carbon dioxide that will interrupt our result. And then we will do, to get the pH 12, we will titrate it with 2 molar sodium hydroxide, put it into the oil bath shaker for 18 hours and 70 degrees Celsius. We centrifuge it for about 25 minutes, 3 times, and then we wash it with we wash it with deionized water, and then put it into the oven. Next. Okay, for synthesis of calcium aluminum 4-CPA nanocomposite, okay, the same procedure has been done, but in this for this time we add 125 milliliter 0.10 molar 4-CPA into our experiment. Next. So for results and also discussion. Next. So the PSRD figure demonstrate the PSRD design for the responses of calcium aluminum IDH host and also calcium aluminum IDH 4-CPA nanocomposite. From the diffractogram, which is the black color, the calcium aluminum host presence of the sharp high crystallinity and also intense peak can be observed at 2 theta at 2 theta 10.35 degree. The Basal spacing is calculated using Bragg's law formula, and the result obtained was 8.54 Armstrong. This Basal spacing is indicate that the interlayer gallery of the calcium aluminum IDH accommodates by counter anion, which is water molecule and also nitrate. Apart from that, in the interlayer as well, the amount of water molecule depends on some considerations such as counter anions distinctive, the water vapor pressure, and also it also its surrounding temperature. Then the basal spacing recorded at 8.54 Armstrong. Actually, it is a good agreement with the sum of the thickness of the anion nitrate ion, which is 4.1 Armstrong, and the brucite layer, which is 4.8 Armstrongs. Okay, and then for the calcium aluminum 4-CPA, which is represented from the red lines, it's synthesized through the co-precipitation method. It displays a slightly shifted downward from 2 theta 10.35 degree to 8.85 degree, which represent the sharp high crystallinity and also symmetric peak with the basal spacing of 9.98 Armstrong, which represent the wider basal spacing after the integration process took place. Okay, next. So this is the illustration what happening during the integration from the ADH host to the ADH 4-CPA nano composites. Okay, next. Okay, this actually this is the illustration of the molecular structure and the proposed spatial orientation of calcium aluminum 4-CPA ADH nanocomposites. As we can observe that from the increase of basa spacing of nanocomposite, the gallery height of the interlayer region of the nanocomposite after the subtracted with a layer thickness of the calcium aluminum ADH, which 4.8 Armstrong is 5.4, and then we can conclude that the this reason can be deduced that the anion were oriented in a monolayer arrangement in between the interlayer regions of the ADH due to the consideration of 4-CPA molecular structure and charge orientation. Now for the FTIR, the FTIR spectra show 3 different infrared bands which were prepared using calcium nitrate and also aluminum nitrate non-hydrate. The most important peak or aspect to highlight is from the presence of the nitrate group band, which is at the range of 1350 to 1400 wavelength. So this peak should disappear or decrease in density to confirm the successfulness integration between calcium aluminum and also 4-CPA. So the calcium aluminum host has a broad peak corresponding to OH stretching at 3567 band appeared as a bending vibration of water molecule. So the calcium aluminum 4-CPA nanocomposite as shown in the figures indicate that both nitrate peaks from the previous result, which at 1354 was disappeared and showed the 4-CPA, and it shows that the 4-CPA was successfully integrated with the layer. Okay, so next. So okay, next. So in conclusion, we could conclude that the calcium aluminum host was successfully synthesized. The calcium aluminum IDH 4-CPA nanocomposite at constant pH 12 has been done through co-precipitation method, and from the analysis of characteristic from PSRD, the basa spacing has been increased from 8.54 Armstrong to 9.98 Armstrong, and for the FTIR, it is obviously seen that the absence of nitrate peak and the presence of carboxylate ion, which is represent the 4-CPA, which was represent the 4-CPA anion. Next. So for conclusion or future works, more characterization should be done by using CHNS, SAM, FISAM, BET, and also TGE, DTG. And the further studies on the properties of calcium aluminum ADH 4-CPA nanocomposite as an effective nanocarrier, maybe we should test this material with control release properties. Next. So thank you very much. So for those who are interested in this research or have any queries, you may scan this QR code. Maybe we can discuss it later. Thank you very much.
Thank you, Dr. Ahmed, for your Sheikh Ahmed, for your nice presentation and nice work. Now the floor is open for the question. Please, audience, ask your questions or queries if you have.
What is the interaction between the calcium aluminum LDH with graphene? Can you propose any idea?
Pardon, sir? I cannot hear you.
Yes. What is the interaction between graphene oxides with your calcium aluminum LDH?
Oh,
Can you stop?
okay. Actually, the anion itself will give a negative charge, and also the calcium aluminum layer itself will give positive charge. So there will be some electrostatic electrostatic charge over there. So that negative charge will be attached to the positive charge.
Calcium aluminum hydride, calcium aluminum LDH, it is hydrophilic or a hydrophobic?
Pardon?
It is a hydrophobic in nature or a hydrophilic in nature?
In nature, it will give you negative charge. But when we synthesize it, it will give you positive charge.
He's asking hydrophilic or hydrophobic, I think.
Pardon?
No, that's Dilip.
Yes.
Are you please
Yes.
repeat your question once again?
Yes, ma'am. It is a hydrophobic in nature or hydrophilic in nature? Yeah.
It is okay from the literature review. It is more to hydrophilics.
Thank you.
Okay, any other question? Okay, thank you. Thank you, Dr. Sheikh Ahmed. Very nice work and nice presentation also.
Thank you.
Thanks. Congrats on that. Okay, now we
Madam, I'm
invite.
requesting you, you can go ahead with 209.
Yeah. Next, na? Yeah. So now we can invite Dr. S.K. Verma to present his work. Dr. S.K. Verma, please present your work.
Yes, ma'am. It is audible to you.
Hi, yes.
Is it audible to you, ma'am?
Hi, yes, it is
Yes, sir.
audible.
Yes, sir, it
Please
is
go
audible.
ahead. Okay.
Okay.
Welcome.
Thank you, ma'am. Thank you. So I'm S.K. Verma from Government Dungar College, Bikaner, Rajasthan. And here I would like to present my research paper that is entitled 3D metal complexes of a didentate heterocyclic bioactive ligand, microwave assisted synthesis, structural characterization, and antimicrobial evolution. Next, please. Yes, so it is my research plan. First, we have synthesized bioactive ligand, that is 2-hydroxynicotinamide. Then we have made transition metal complexes using 4 metal ions, Mn, cobalt, nickel, and copper second ions. The synthesis of the ligand and the metal complexes has been done by a green method, microwave assisted synthesis. And then we have also done antibacterial studies using disk diffusion method. Next, please. Yes, why this spatial ligand has been selected to prepare the complexes? Because it is the 2-hydroxy derivative of the biopotential compound nicotinamide. And nicotinamide has crucial role in various metabolic processes such as glycolysis, fatty acid synthesis, respiration, and also has effect on protein and RNA synthesis. It is an essential component of vitamin B complex. It is also have been successfully used in treatment of pellagra, psoriasis, and schizophrenia and type 1 diabetes. And so many complexes of nicotinamide has been found to have anti-tumoral, antiviral, and antibacterial, antitubercular activities. Scope and objectives. So to design microwave assisted synthesis, to characterize and to find out the biochemical utilities of the selected bioactive ligand and their complexes was the main scope and objective of the present work. And here we will also understand the coordination behavior of the ligand and the pattern of bonding with the transition metal ions in the complexes. Also, the biochemical investigation on these complexes will provide screening towards the development of novel drugs. It is the synthesis plan for the ligand. We have synthesized via both the methods using conventional method as well as the Green's method, that is microwave irradiation method. So we have synthesized using microwave irradiation in presence of NH4OH and solid NH4Cl and the duration for microirradiation was 3.5. And this ligand 2-hydroxynicotinamide was synthesized by its precursor 2-hydroxynicotinic acid. Next, please. Synthesis of metal complexes. We have synthesis complexes via both the methods, conventional as well as green method. The green method is represented here. That is, we have done with the help of green microwave bioreactor that is established at our research center at Government Dungar College, Bikaner. And in this method, we have made one slurry of reaction mixture and was exposed in a microwave reactor, that is GMBR, at 1600 watt at different type of interval with occasional inspection and definite inspection of TLC data. The mixture was cooled to room temperature and poured into ice chilled methanol and dried in vacuum or P2O5. So then we separate and crystallize the metal complexes. Next, please. Physicochemical data of ligand and complexes. Here we can observe the physicochemical data, color, melting point, reaction period, yield, and the data of an elemental analysis. The data of yield clearly shows that the microwave method is far better than the conventional method for the preparation of ligand as well as for the preparation of complexes. So here we can see the beauty of green chemistry that also gives plus points to our research work. Next, please. Vibrational spectral assignments of the metal complexes and the ligand. Here the frequency change, decrease or increase in the amide first band, amide second band, and amide third band clearly shows that the ligand uses both the oxygen atoms as donor atom, and it is behaving as didentate ligand to form the complex. Next, please. Magnetic moment and electronic spectral data of the complex. Here we can observe the RF values of the metal complexes, their value of magnetic moment, electronic spectral bands, and their tentative assignments. On the basis of tentative assignments, we have concluded the expected geometry. Previous one, please. Previous one slide. Yes, the expected geometries are octahedral in case of MnCO and Ni, and in case of copper, the complex have distorted octahedral geometry that we have concluded on the basis of asymmetric broadband that we have found in electronic spectra. And the tentative geometry is also shown here, where the ligand using both the oxygen atom as donor atom. Next, please. One additional feature that we have found in our research, that the ligand to hydroxynicotinamide that shows keto-enol tautomerism and possibly exists as the keto tautomer, not as enol tautomer in solid state or in our complexes. So that is based on the conclusion from the FTIR spectra. Next, please. Biological investigation also has been done, and standard disk diffusion method we have used, and 3 bacteria subcultures, E. coli, S. aureus, and B. subtilis, that we have used. The study clearly indicates that the bioactive ligand and the complexes possesses at least one type of biological activity up to substantial level, and antibacterial activity of complexes in most of the cases have been found greater than the respective ligand. Next, please. These are the photographs of biological activity showing the zone of inhibition. Next. A comparative result of biological activity with respect to all the 3 bacteria subcultures against E. coli. We can see that the Mn complex and copper complex, they have greatest activity. And against S. aureus, Mn and cobalt complex, and against the Bacillus subtilis, the nickel complex have the highest activity. Conclusion and future works. The complex of 2-hydroxynicotinamide with the 4 metal ions have octahedral geometry, while the copper complex have distorted octahedral geometry. All the prepared bioactive ligands and complexes have effective antibacterial activities against E. coli, S. aureus, and B. subtilis bacteria. Microwave assisted synthesis is an efficient method for synthesis, having high yield and less reaction period in comparison of conventional heating method. The future works are preparation of single crystal and X-ray crystallography studies of complexes, antimicrobial activities against selected fungi, and docking study of metal complexes. Next, please. These are some photographs while I was pursuing this research work. Next, please. Thanks to the team, Green Chemistry Research Center, Bikaner, my Department of Chemistry at Government Dungar College, Bikaner, and also CRO UGC Bhopal. Please, queries are invited.
Thank you for nice presentation by Dr. S.K. Verma. Participants, if you have any query, please ask.
Sir, one question. This is Dr. Ramana from GITAM, Bengaluru, sir. Sir, you mentioned that
yes, sir.
keto form is observed by that IR, right?
Yes, sir.
Yeah. Can you tell me what is the main reason? You know, mainly more stable, right? How can you explain that? Just
sir, the keto form is identified on the basis of FTIR spectra of the ligand.
Yes, yeah.
And also from the FTIR spectra of metal complexes. So here, because of the time limit, I was unable to explain all the IR spectral bands that we have observed in the IR spectra.
Okay, I will contact you, sir. I will discuss.
Okay. Thank you, sir. Thank you.
Thank you.
Okay, sir. I have.
Okay, Mr. Vinay Kant has some question, I think.
Yes, sure.
Vinay Kant, unmute yourself and ask the question.
Hello.
Yeah, Vinay
yes,
Kant,
please.
Sir, can you please tell me how you incorporated your compound into the disk for evaluation of antibacterial activity?
So that is a standard method for evaluation of biological activity.
Yeah, that I know.
That we follow in case of every biological activity, to check biological activity in every case. That is not very much related to this research work, basically.
No, your compounds were whether water soluble or
no, they were alcoholic. They were soluble in alcohol.
Okay. Thank you.
Sir, my doubt is the heat transition that you have assigned. Are those theoretical, or did you do the UV from 400 to 800 and assigned it?
No, they were observed from the UV spectra itself.
Okay. No, tentative you have mentioned, so I thought maybe you are assigning it just not experimentally, theoretically you are explaining it.
No. They are experimental assignment and experimental bands were there.
Okay, that's good. It is in a normal spectra, it is there, or you have to deconvolute it and then see it?
I'm not getting your question clearly, ma'am.
No, was it there in a normal UV spectrum, or did you have to deconvolute the spectrum and get the 4 bands for absorption peaks?
No, in the normal spectra.
Okay.
We have used double beam UV spectra to just observe these peaks.
Okay. Thank you.
Yeah, thank you, Dr. Verma. Yeah.
Yes, sir. Thank you, Nagaraju, sir. Nice to see
good
you,
to see you.
A very good experience for
good to see you also, sir.
Conference.
Madam Anjali, madam, is there? Madam?
Yes, sir.
Yes, madam. You should conclude, madam. There is no more oral presentation of this session. Madam, your voice is not audible. Madam, your voice is not audible. Yeah, thank you so much for the participants. There is no more oral presentation now. I think we'll go with invited talk by Dr. Moses from Kenya.
Yes, thank you, Dr. Keru.
Dr. Moses, good to see you, Moses.
Yes, I'm here.
How are you?
Fine, thank you. Do I share my screen or you?
Wait for a few minutes. I will introduce you, and then after you will share your screen. Yes. Madam Prof. Anjali, madam, your voice is not audible and your video also not visible.
Yeah, Nagaraju, please go ahead.
Okay. Thank you, Dr. Moses Abdingo. Thank you for accepting my invitation and requesting for the invited speaker to my international conference. Along with me, one of chairperson is Prof. Anjali Jaha. Madam, unmute yourself, madam. Madam, unmute yourself.
Good morning, sir. Good morning, sir.
Yes, she is Prof. Anjali Jaha. Madam, you can tell me.
Yes, sir. Good morning, sir. We welcome you, sir, for our this 3 days international e-conference. We welcome you, sir, for your invited talk. I am Anjali Jha from GITAM University, Visakhapatnam. So, okay, Nagaraju, you want to tell or shall I invite Dr. Venkat Ratnam?
Yeah, go ahead, madam. Go ahead, no problem.
Okay. Good morning, sir. Good morning. Now I invite Dr. Venkat Ratnam to introduce our today's guest, Dr. Moose Abenego Golengo from the GITAM Kimat University of Technology, Nairobi, Kenya. We welcome you, sir. Dr. Venkat Ratnam, please introduce our guest.
Oh, thank you, madam, and good morning, ladies and gentlemen. It's my pleasure to introduce Dr. Moses Abdingo Olingo as an invited speaker today. Currently, Dr. Moses working as a Directorate of Research, Dedan Kimathi University of Technology, Kenya. Dr. Moses received PhD degree at University of KwaZulu-Natal, Durban, South Africa. And after that, he has joined as a postdoctoral fellow at University of KwaZulu-Natal, Durban, South Africa. Dr. Moses has experience in nanotechnology, nanomaterial synthesis, characterization, and green energy device fabrication. Fabrication of nanocrystalline, cellulose, graphene oxide composite structured films for the application in flexible energy storage, optoelectronics, spintronics, and electronic devices. He has published 38 articles in the referred journals and 1 book chapter and has secured 2 patents. He has received various grants, East Africa Community Scholarship Program, Geothermal Energy Technology, Global Challenges Research Fund, Networking Grants, and Technology Innovation Agency Award. And Dr. Moses, welcome you, and screen is yours.
Thank you. Thank you so much, Dr. Venkat. Much appreciated for that kind introduction.
Thank you.
I would wish to request that probably I share my screen so that we can go right into my talk today. Now, that's my name. As Dr. Venkat has just said, I'm from Dedan Kimathi University of Technology. You might need to know where the university is. This is located in Kenya. This is our country. And if you look at the middle part here, that is where Nyeri is. When you are at Nyeri, subterranean environment, you can be able to see the very beautiful peak of Mount Kenya. Our temperatures here range between 12 to a maximum of 25. So we never experience any hot conditions. Our university is nested within that kind of serene environment. And if you look at it, that is our university current location. This is the one speaking to you. And the boss of this university, Professor Engineer Kioni, is the Vice Chancellor. So this is the kind of serene environment in which you operate in. I'm from the Department of Chemistry, in as much as I'm also the Director for Research, Innovation Management, and Community Linkage, which is housed in this building right here. So today, I want to talk about some of the work that we have been doing right from 2015 from the University of KwaZulu-Natal, which I continue holding research collaboration in terms of student supervision and also doing continuing with the part of the work, because the span of work I'm trying to present today is part of intellectual property that we are still pursuing. And so there could be some slides which have been deliberately removed because they are still under consideration in the European Union and also in the US, where our patent applications are still in progress. But today I want to talk about something very interesting. And as you can see, graphene and graphene-based materials are playing an important role, especially in nanotechnology, in driving various sectors. Be it in terms of nanomaterials, in terms of microsystems that you can see, and also in terms of biosystems. And when we talk about systems, you're even talking about body implants, which are very, very crucial. Now, when we talk about materials, you're also looking at things like sensors of important applications in industry. And from where I come from here in Dedan Kimathi, we boast of a science and technology park that has attracted a huge clientele in various areas of research and application. We are doing a number of innovations, especially in electronics, bioimplants, environmental sensing systems, and this has found an immense application, especially with my pet graphene oxide and various graphene-based technologies that we are incorporating. Now, when we started with the use of graphene, oxide, we were looking at how best can we be able to integrate it into other composites that will find immense application. An area that really propped up is a renewable material that's easily propped up was the cellulose. Now, basically cellulose, one would argue, for us from the agricultural sector, we would think it was a waste. You find leaves rotting, you find barks rotting, you find sugarcane waste just rotting on the field, basically without proper utilization. But now, from the work that we have done, we have realized that cellulose is an important plant-based material that can generate a number and find applications in a number of fields. For example, of interest, which I'll talk about today, is nanocrystalline cellulose. But I'm aware that we could be able to have the cellulose hydrogels. We could also use it to get regenerated cellulose and bacterial cellulose for various applications, especially in biosystems and sensors. And for today, I will spare this and really zero down to nanocrystalline cellulose for an important application. Why are we doing this? We are doing this because we have a thirst for nifty materials. And these nifty materials are the driving force that normally shape the dynamics of our future technologies. We are looking at materials that are able to give us a certain kind of applications or characteristics that are beyond the expectations that we had. One of the areas which is important is the piezoelectronic ceramics. You go to your gas cooker, nowadays we can be able to, you don't need a matchbox. We talk about piezoelectric polymers, rheological fluids. Rheological fluids are electrological fluids are very important to drive even muscles in robotics. We are controlling fields, for example, magnetological fluids. We are also looking at memory storage. And one of the things that we are doing at the University of KwaZulu-Natal is how do we expand the memory shape, the memory capacity. And that calls for an important component of the topic of understanding the electroactive polymers. And initially, we would look at graphene oxide as perfectly somehow appearing to be an insulating kind of, because you know the sp2 channels have been blocked by sp3 due to introduction of heteroatoms, for example, oxygen and the rest of other things that we can quickly input on the graphene structure. But that alone introduces other important aspects of interest for us, and that's why we are saying, as much as it has an effect of electroconductivity, but it's polymeric in nature, the way it appears. So it can help us improve memory, improve energy storages, and the rest of things of interest. But there are certain challenges when you're looking at materials. One of the major challenges that we really need to look at in the current dispensation is how eco-friendly is the type of material you are using, right? We are looking at, even if it's eco-friendly, how sustainable is it? Because the current economies, and we are looking at how to drive the discussion in terms of how we conserve our money and our expenditure. So apart from just being eco-friendly, it must be sustainable. And now when it comes to sustainability, we need also to address how renewable is the material, right? Will it prevent the ecosystem loss, the global warming effects and diminishing energies? And how do we use it without diminishing the productivity of the gadgets? Because we're looking at hard and rugged and economical aspects in everything that we intend to do. And that's why one of the things that we thought about is from the agricultural sector and where I come from and where I am, this material lying in the field. We go to our coffee farm, we have husks that are just thrown there. We go to our sugarcane plantations, the wastes are lying all over. But we can be able to get the nanocrystalline cellulose, and because they have the functional groups, we can be able to modify them and apply them. Now, in this respect, we discover that the nanocrystalline cellulose have some of very excellent phytochemical properties. One of them is that they will obviously decompose, so they are biodegradable. And again, you are able to elongate the chains. You are able to adapt them, to incorporate them in systems. You're able to make them into very good display composites that have got exceptional characteristics. One of the things that we noted is the presence of off-diagonal forces that actually most people had not looked at earlier on. And when you incorporate it in an already an sp2 channel kind of mesh, for example, with graphene oxide, we have sp2s and then sp3 kind of carbons. And that means that we can use the off-diagonal forces to basically change the electroconductivity of the material. And that's why we found one of the patents that we already secured so far is that we can basically change a P conducting to an N conducting. We can do all sorts of things just because of capitalizing on off-diagonal forces and also creating supra kind of conductivity of the plane conductivity, which was not foreseen earlier. The other aspect is that the NTC also displays a very low density specific barrier properties. One of the things that they have got very good thermal coefficient, high strength, excellent stiffness, elongation mobilities and inertness, large surface area, and aspect ratios that are burdens for ease of bioconjugation. You know, these are very, very excellent characteristics. And now when you look at the low thermal expansion coefficient and stiffness, then we are saying it can be very good material for motion induction. And that's why in this talk, I want to talk about its application in some of the works that we are doing and the composition. Probably I may not go into that because I have made it in terms of kind of critical review. But one of the aspects we are doing is that we can use it as an actuator, as a motion mover, can be able to receive signal, because we know we have already done this. And we have seen that if you incorporate it with an UV absorbing medium, then we can drive it. We can use a photoacoustic motion moving. We can also use light. We can use electric current signals. And this will obviously change. So the presence of several reactive chemical groups on its surface allows it basically to be to have various physical adsorption, covalent bonding, or surface grafting to further extend the performance. And now this is what most people obviously know. And if you have, these are basic cellulose in the structure. So when with this kind of groups that we have here, one of the things that you'll notice that it is hydrophilic. And that means in the presence of moisture, there's tendency to incorporate it into the structure because that attraction exists. Now, when we start now trying to restructure it so that we can have a formal way of conductivity or formal properties, then we do what we call acid hydrolysis. And in acid hydrolysis, we are trying to shape it so that it can be able to be harnessed in some compact way. It can be able to appear crystalline. And crystalline means we are increasing long range forces, allowing those, what I've just told you about, the issue of the off-diagonal forces that appear to be affecting the various physical chemical properties of interest. Okay. Now, if you look at this, that this is normally in a disordered form, but when you start doing acid hydrolysis and strong acid, we expected to have a kind of structures like this. The ones that you just saw, we have tried to mark them out in this way. Now, in this respect, when you look at it from CM perspective, this is a TEM image, you will basically see things like this. But what you expect to see around this, we have got whiskers. These are important to us because they are able to invite molecules, and those the invited molecules will help us induce motion. And that's the effect of today. We are looking at an actuator. An actuator is a component of a machine that is responsible for moving. That's the basic definition. So it's a mechanism or a system, for example, that can open a valve, can close a door. But you see, the kind of work we are looking at in the current dispensation is we want to look at robots. I want to look at machine operations at very high sensitive limits. In this respect, we are saying that we need things that are able to respond to control signals. And our signals may be at even very low current or very little amount of light or photoacoustic. We can also induce, we combine light and sound because, you know, this is basically energy. Energy can be transferred from one form to another one. So we are saying, assuming that we want to target molecules in a system, in a body, in a human system or a living system. What else do we need to do? We can use light to induce a percolation. We can use sound to convert it into a motion. Now, this is our subject today. We are looking at motion control. So we are saying that we want to be energy sensitive. So we want to control the signals from relatively low energy. This could be electric voltage. It could also be a push in terms of pneumatic or hydraulic pressure, or an even human power, right? Now for received signals, an actuator is expected to convert that source energy into a mechanical motion. And that is the most important beauty of the combination that I have chosen today to talk about. When you impregnate graphene oxide or you impregnate graphene oxide with nanocrystalline cellulose. I've just said that we have the whiskers around the roads. And you see, you know what? Those whiskers are OH groups that are flying around. And that means they are hydrophilic, they are able to absorb. Now, when they come into, they change the symmetry, they change the organization. Now, basically, when you look at it from the group theory perspective, you could look at them as asymmetric layers. So basically, we are forming sheets that are asymmetric in nature, and therefore, because of the varying charges around it, in themselves, they have the ability to have to have charges which can be induced on the surface. They can reside. Now, depending on the amount of the sp2 carbons present, then we can have varied type of conductivity, but also we can also have varied type of charge transfer characteristics. Obviously, in this case, graphene oxide in most cases, what we know is ambipolar, and therefore we can basically modify depending on the type of configurations that we have. So what is important in this case, because we are impregnating the molecules, then the important bit that we need to look at is the flexibility. Now, if you look at the graphene sheets themselves, or graphene oxide sheets, they appear flaky. So what's important here, you need to introduce flexibility. Now, flexibility here, you introduce it with the incorporation of the nanocrystalline cellulose. Now, I've shown you that there is a linkage, the glycolic linkages, that allows this particular sheets now to be a bit more flexible. Now, if they are flexible, then it tells us that now we can be able to have very important applications. One of that is artificial muscles. We can now use them in robots and optical devices for closing and shutting and so on. They also have a number of the most conventional actuators. One of the things we can have is actual actuation functions. But now the other thing is that, you see, normal cameras and things like that, the actuators may not have a real-time sensing signal feedbacks. And that's the undoing of the conventional actuators. One of the things that we want to attain in this project and in this work that we're focused in is to have a real-time signal feedback system. That tells us that whatever we have developed is quite intelligent and that it can be able to give us real times, real reflections. It can give us, it can be attentive enough to show as and it can be able to show an actuator is very key when you talk about robots and when you talk about implants, especially now we are moving into research in areas where we are developing artificial hands, artificial limbs. Those things require inbuilt actuating with real-time feedback, and they can respond to light. And when they respond to light, they are able to give us certain types of functions. But that functions can also be attributed to piezoresistivity that is introduced in the system. And that's how it comes about. But because, you know, we are looking at the nanocrystalline cellulose, and they're quite in small order. They also have issues of a bit of thermal resistivity. And for reduced graphene oxide and especially in paper composite form, this becomes a key aspect in terms of inducing the bending motions. And then we can also be used as a strain sensor to monitor human motions, and especially when you are looking at medical devices for implants. It becomes a very key important aspect. Now, the other aspect is if you're using it on human limbs, for example, hands, then you are talking about how it can grip. So smart grippers, basically, this is a key area for to demonstrate the same. Now we're saying that smart grip based on actuator demonstrates very perfect integration for actuating and sensing. And the idea we have here is the use of these particular composites because of the characteristics I'm going to talk about. Now, look here. We have an ordered point where we showed those kinds of crystals because I said they appear like blocks. They are normally pencil-like, but they are very ordered. And then when you look at the disordered surfaces and the glycolic links between them, this allows this particular thing when you input in a signal to be able to bend. So basically, it can be used as a switch, and as I'm going to show you. Now, in the current trends, people have used polyethylene ethoxyfuels, and this to cause this kind of disruption, but also a beautiful disruption that makes sure that those layers do not get disrupted or do not get broken, because we are trying to say we want this to bend several times without basically breaking. And how do we do that? We incorporating things that probably could conduct. These are experiments done by some colleagues, and most of the references, all this work is acknowledged at the end. So that's kind of work. Now, if you look at, this is what we did, have done at the University of KwaZulu-Natal, and what we realized is that when you put it in the hand, all right, expose it a little, you can see it folding. What time there, it's responding to the moisture in the hand. But again, it can also induce, this is for part A, it can also induce, and these ones were done at various compositions, it can also induce a rocking motion because of the sensing of your finger. Now, if you look at that, that is an important characteristic, because what we knew is that this composite can as well be able to conduct, and we have done that. What I'm showing you is the 10 seconds, 11 seconds, those are different compositions of the composites. So, and their type of the ability to sense moisture is different. So it therefore means this: you can be able to place it in a particular moisture environment as a sensor, but again, when you connect it to an active circuitry, it can also give you a real-time feedback because of the charge induced, right? And that is what we are showing here in the second rocking motion. When you look at this one was now done, but with the introduced silver nanowires. When you introduce silver nanowires, it performs so beautifully, it can be able to light even an LED, but on itself, it shows a rocking motion just by a bit of a sensing or introducing on a substance that appears to have some moisture. So that's the kind of work we are saying, that because it can sense that, and then we can see a motion, it can conduct electric current, and that, once you can see that there's a conduction of electric current, it means that be it in a biological system, be it in a normal light, in a normal circuitry, be it in an acoustic environment, then you are able to induce charge flow. And you see what? Induction of a charge flow is an important aspect in signal transmission, signal detection, and signal processing, and then also signal memory storage devices. It's an important caliber in terms of feeling for what we can be able to see. But that motion alone is what is of importance for our talk today, the actuation of the moving function. Now, how do we induce that? Now, for polymer chains, what we know that these induces an inter as well as intramolecular expansions. This can lead to multi-electrostatic repulsions among neighboring chains. And we can collect this. In most cases, the kind of work people may do, and that's why we throw away materials. You're in the lab, you are testing for air, and then you feel you are not responding because you don't. Most times we don't pay attention to charges which may appear on a bulk scale useless, but at nano level very useful. And that's why you can picture for what we can picture here. The inter and intramolecular expansions are literally not noticed, and therefore, but now when it bends like that, is the same thing aspect that we can see in be able to getting a bulb lighting, right? That was not initially identified, but now I've seen several working groups have been demonstrated. Like this was demonstrated by Gao and the co-workers. I've acknowledged them at the end of my talk, and you'll see the references. Now, how do we get this done? Now, the graphene oxide has functional groups on the surface, like in this manner, and therefore it also means that we have those carboxylic groups, we have OH groups on the surface. Therefore, means that it is also a bit of a hydrophilic. It can be able to absorb moisture. So when you combine it, now, and those in between those layers, the blue ones here are the water molecules that can easily be embedded. When they get embedded, the bulk changes, and that bulk changes are the ones that now attributes to the induction of motion. Now, these are smaller sheets. If you look at from your SEM, what you will see, they appear like flakes. Now, those kind of flakes, they need to be held together. And so when we bring in the NCC into this, we are telling you that we are also introducing some form of binding, some form of higher level of moisture sensing, because there are two materials that are very good in moisture. But again, we're also saying we are introducing a bilayer effect, and therefore there is a charge residence on either sides. We're also telling you that in this case, that we are binding them, that there's likely to be a more elongated, higher stiffness, and we are not likely to break. So the sheets are likely to get more promising work along the way. So that's why now we introduce those kind of rods in there, and those rods are interconnected by van der Waals by the glycolic bonds, and as I had shown earlier. So producing this kind of bending under moisture, you can easily notice that it becomes quite important, and that now the flaking or the bending and the stretching forces on the surface can be sustained for as long as it is within the performance range, within the Hooke's law. Now, with that in mind, we are telling that the actuating materials have therefore experienced booming growth because of their fascinating applications. Firstly, in mechanical systems, also in the using of artificial muscles. What we should be not blind to is the fact that we are in the area, in the age where we are trying to provide solutions for the medical field in terms of artificial hands, artificial limbs. We are also trying to put in implants, we're also looking at how we can activate speech within the living systems. And that's why we have this kind of, the actuators are becoming very, very important to us. Okay. Now, then we are also looking at the type of materials that can do this actuating. And that's why we have liquid crystal elastomers, that these have an incorporation of the graphene-based materials. We're also looking at the electric elastomers, paper-based materials of importance today, hydrogels and carbon-based materials. Now, the driving force, therefore, when we move from the physical, when we move from the actual material, when we move from the actual chemical composition that now allows us to harness this, then we have to look at the drivers. And the drivers here could be heat, either could be thermal resistivity, could be electrical, could be light, could whether be pH, just the sensing of magnetism or humidity, or we could have a combination of the stimuli, both heat and light, or we have sound and light, photoacoustics. We could have magnetological activities. So this, we could be able to combine them. Now, what you can know is that the conventional actuators can only be acquired through, for example, typical camera systems, imaging, handling technology, which in most cases is inefficient and not suitable under inadequate lighting situations. Because then that's why we are saying you need to be able to pick the other extra electron on the surface. You need to pick the other extra swelling because of humidity. You need to pick the other extra pile up in terms of accommodation, group accommodations. And that's why we are saying, even in graphene oxide and nanocellulose, crystalline cellulose, the hanging, the whiskers are important. Now, this adds in the sensing function to the actuator. Then the sensing function is it bent, but there was a charge which produced some light, or bent and produced some charge conductivity. You know, it introduces us to sense something happen. So we can also use that, can accurately view obtain deformations, the degree of the actuators, and actuators can also be controlled automatically, giving us real-time feedback. Now, for that case, it means that we need to integrate. We need to integrate several systems together. Now, in this case, we are looking at low generated stress, long response times, and hysteresis. In most cases, when a charge moves, then basically there's a magnetic field. So what is important is then how do we reduce the hysteresis loop so that we have a sharper response time? And that's why the carbon-based actuators have been reported to be very good in sensing functions, because you know, the hysteresis loop for them are very narrow and very sharp. So the idea here is we can basically get human-related applications, which are important in terms of smart electronics and textiles, wearable soft electronics, soft haptic electronics, disposable active bio medical devices. And this requires high performance soft actuators. And that they should be bio-friendly. When you incorporate them in the biological system, it must be incorporated. We have never seen, we don't have reports of nanocellulose poisoning. We have very limited report on the use of carbon graphene oxides as poison. So if there is any, I'm open to understand, to also be educated with the same. But what we know is that they are highly biocompatible. There's very good reported biodegradable functionalities. So in this respect, we are saying that we have looking at basically membranes that are very, very porous. If you look at their openings, that it's about 6 angstroms in terms of the width. And this changes not only mechanical properties for memory, but also they have very high bending recovery rates for these membrane-based actuators. And that is why we are saying graphene oxide and crystalline cellulose finds a very important use, because it's porous, it's a higher recovery time. We have charge induction on the surface. We have the issues of off-diagonal forces that be able to sustain and modify charge carrier characteristics. So all this adds up to what you call a geo-NCC membrane. That is biocompatible soft actuating material with quick response time. And also operating at low voltage and comparatively large bending deformation. So electroactive polymers, in this case, where this composite fits, because of their large bending deformation in response to electrical stimulations, they can easily be called artificial muscles. And that means the application robotics, bionics, is guaranteed. Now, in conclusion, then, I should say that the traditional noble metallic electrodes in most actuators of current systems, the following things you need to know: that they have cracking of metal electrodes, they have very low stretchability, that will not cause time consuming the processes. The other aspect is that the degradation of the polymer electrode and the lack of reproducibility. They also lack of environmental friendliness, right? That is heavy metal doping and contaminations and things like that. There's also the issues of electrode materials, limited resource, and because they are noble. Normally you talk about gold, you talk about silver. These are noble metals, they are not cheap. That makes even the technology and application. And that's why one of the reasons why biological implants are very expensive. Because of the kind of material they use. So in a nutshell, our work is to get biomimetic actuations and with the large bending deformations, flexibility, very lightweight and relatively low cost, so that everybody else can afford. You have an accident today, you need to have a replacement or to have artificial hand. You need to get it cheap. And how do we get it cheap? By ensuring that the cost of production is low. And how do we get the cost of production low? You have to get the materials that are that can be made at very low cost. That's the idea. Now, these characteristics basically make electroactive polymers very attractive candidates for various applications, especially to mobile flexible displays, wearable electronics, soft acting devices, and electronic textile biomedics, sensory actuators, and biomedical devices. Now, the actuation performance is mainly determined by electrochemical mechanical properties of both the electrolyte and the electrolyte materials. So it's very important that we look into this and we bring it on board, and that's the issue. So most of that work are borrowed from those kind of references. There are quite a number, and if you look at them, they are very current because that's the most current work we are doing at the University of KwaZulu-Natal. Thank you for listening. We'll invite questions. Thank you.
Thank you, Dr. Mose, for your wonderful lecture on that actuator mechanism. Especially, I like you have shown very nicely that with diagram how it works and all that. For any layman also can understand very nicely. Thank you very much for your wonderful lecture.
Okay.
Okay. Now I ask all audience. You can ask your queries to Dr. Mose. Audience, you can ask your queries. Are you able to hear now, Dr. Nagaraju, my voice?
Yes, madam. You are audible.
Okay.
Yeah, Dilip Kumar Misra is responding.
Okay. Okay, Mr. Dilip, you can ask.
And Dr. Giri also. Giri, speak
Now,
something.
so many people are working on this graphene oxide and all. That is very useful material and all. So you people can ask some suggestions from Dr. Moose so that you can improve your research, I believe. And sir has shown so nicely that all hand and all. I just liked it very much, like how it will move and all. Sir, I'll contact you, sir, for your help. Either.
No.
Madam, if you no more queries and questions, we will conclude the session, madam.
So now with the wonderful lecture by the Dr. Mose from Kenya, we just want to conclude. Before your lecture, sir, we had 9 oral presentations, and all presenters they have presented very well all their work. And people, that audience also, they raised the questions, and I think they clarified, and in between the mail also they have introduced. So if anyone is having any queries, they can contact always the organizer, GITAM University Bangalore campus, and you can you can get the contact from the all presenter as well as Dr. Moose. Thank you, Venkatnath sir, for giving me this opportunity to chair this session. It is wonderful experience. Thank you very much.
Yeah, thank you, madam. And
Thank you, Nagaraju.
thank you, Dr. Moses. Thank you so much for accepting my invitation and wonderful talk. And personally contact you again, and we'll collaborate each other in future also.
Thank you.
Yeah, thank you so
I
much.
much appreciate the organizers. God bless you.
Yeah. Thank you, Dr. Moses.
Thank you.
Madam, and another announcement, madam. I think we have a next session. Start with 1 o'clock to 4 o'clock. It is an Prof. Edith from South Africa. She is also belongs to material research and some other biological application, as well as photo degradation and photocatalysis application. I hope next session also participants can enjoy that session also. I think they will share some knowledge about regarding the materials research. I hope I'm requesting all the participants. We'll meet on 1 o'clock. That's the
same link, na sir? This is same
no,
link.
No, madam. I forwarded them also. I think they have the link.
Okay.
No problem. They have.
Okay, sir. Please forward to me also. That link.
Oh, sure, madam. I will forward to you.
Okay, sir. Thank you.
Thank you so much.
Thank you. So we can conclude this session, na sir?
Yes, madam. Yes. Okay. I will end this session, madam.
Okay, sir. Thank you.
Okay.